Live. 3, 2, 1.
You're gonna edit that out later, right?
Oh, it's already in here. We'll make an edited, shortened version. That's what we got to start doing. I'm gonna start doing that with all the streams. Just make like a cut down, like 10 minute or less version. So because there's so many people that don't have the time or the attention.
Nobody has the time to look through it. You need to go through all the videos and just like make a short, concise packet. That's what what's his name does.
Right. It's cool for the people that do tune in live and get to watch it live, and that's why we started off like this and wait for people to show up and start coming in. And,
yeah, you need to shorten it down. That's what Joe Rogan does. He gets the best points of everything, stuffs it together. I mean, what we got going on over here is pretty much the preamble. So how many people are with us live now?
We're gathering them up. There's 21 people right now. And what's up, Renee? What is up, Fail Forward Research? Gray Troll in the house. How you guys doing tonight? It's Friday night, and the party is here in the lab with Mark Sokol.
I'm actually going to try setting it up on Facebook right now. Let me see this. Server.
Yeah, get more people, man. Join the party. So Mark is live with us down in the lab in New Jersey, and we were just on with David Alzofon. He said he had a problem with his computer and he had to switch machines, and then he came on for 2 seconds just to tell us that he switched machines, and then he was fiddling with something and disappeared on us again. So we're hoping that he tunes in with us again here shortly once he gets that resolved, and that we can get going. We've been spending all week to get him hooked up with the proper lighting and also the proper audio, so that we can get everything recorded and running smoothly and the best quality for people out there. So I'm here, of course. Look at what the hell is this? Where the hell am I? I'm in a new spot, right? So I got my new laboratory kind of set up here. This is my new science lab. We got some cool stuff going on, and I want to show people. I haven't finished this yet, of course. We had to go live tonight, and I didn't have time to get everything set and ready. But it should be set up and ready for the next live stream and podcast. But I got some interesting things that go on with this, and I'm starting to link it up. I got these. I got everything linked up with automation, so I can control it from my cell phone. So if we want to start boiling our lab equipment, we can start boiling some water in the background there, and things start happening, and we're gonna
figure out how to go live on Facebook. How many people are watching? Does anyone know how to do this?
Anyone know how to go live on I know how to go live on Facebook. You go to the video, and then you do like the screen present or whatever. You do like the same kind of present thing. I don't know if there's a way to do it from Zoom, directly from Zoom, but
there is a way to do it directly from Zoom. Live video.
I haven't figured that out yet. Man, we got. That's why we need to get some more. We're gonna get some more people in the house. I'm encouraging more people who are involved with doing podcasts and setting this up. Please contact me at thealienscientist@gmail.com and help us out, get involved. I'm going to have an assistant, Jamie, here soon. My friend, he's coming down tomorrow, and I'm going to have my own assistant here running kind of my podcast for me to help me in the background to pull up images and do other stuff, so that when we can do these podcasts, we're going to try and get them done more professionally. Of course, we're going to do less of the live streaming sort of thing. This sort of thing, I think, is going to be pre-recorded in the future and edited down, because, of course, we have things set up, and then David disappears on us while we're trying to
we're going live on Facebook right now too, and whatever.
Awesome. So yeah, well, hopefully David comes back and joins us. So because that was an interesting discussion.
Oh, one second. I think he's back in there. I just need to add him to the room. Just give me a second.
Awesome.
Okay, admit him. Yeah, he's back with us. Okay. Can you hear us? David, can you hear us? There's connecting with audio.
Hello?
Hello, yes, we are live.
Greetings.
We did it.
David is here, guys. We did it.
The computer crashed for some reason. I don't know what was going on. But anyway, I am here now, and let's hope it stays that way.
Yes, let's hope. David, I'd like to welcome you all to the show. We are live, of course, as you know, broadcasting 31 viewers currently. Hopefully we get some more in the house. And of course, these videos stay up and get viewed repeatedly. So I want to ask you to, you are obviously the son of David. You're David Alzofon, the son of Frederick Alzofon. I have a picture of your dad up here on the screen for our audience to see. And why don't you start by just telling us a little bit about your dad and how and the history of your childhood and growing up with who your dad was, and we'll start there.
Okay. My dad was became interested in science while he was a child. He went to UCLA, graduated in physics and mathematics, and then he went to graduate school at Cal Berkeley in the pre-war years when J. Robert Oppenheimer was teaching at the physics department, and my dad got his MA in physics or MSA, I don't know, master's degree in physics at the physics department at Cal. Yeah, I'm hearing myself. Anyway, his teachers included a long list of illustrious scientists, including Oppenheimer and David Bohm and Victor Lenzen. And I think he's particularly interesting because Victor Lenzen was a friend of Albert Einstein's, and Einstein went so far as to laud him as the one person on Earth who understood his relativity theory better than anybody else. And Lenzen had multiple PhDs. He was a PhD collector. And one of those PhDs was in the philosophy of science, and he studied with Bertrand Russell. And so all of this knowledge about the scientific method he passed along to my dad. Now, when my dad encountered relativity, general relativity, which is the currently accepted explanation for the gravitational field, he felt that it didn't exactly conform to the scientific method. So he decided to go back to the last theory that had to do with the unified field theory, which seeks to unify all the basic forces of nature, including gravitation, magnetism, the strong and the weak force in atomic physics, and reconsidering also quantum physics. So that was pretty ambitious. It took him a while to develop that theory, but by the time I was born, he had pretty well decided it. And he was still working on his PhD, by the way, because of the interference of the war years. And by the way, I don't want to shout too loud. Are you picking up my sound all right? Am I coming through with sound?
I can hear you loud and clear, and the audience seems to be able to hear you too. And no one's screaming out in the chat saying we can't hear you, we can't hear you. Usually that's one of the first things that happens. So yeah,
good.
You're not just talking to yourself, David. We're all here.
All right, good. Let me continue then. 1954, he went to see Richard Feynman at Caltech. At that time, Feynman had open office hours. And he had his theory of gravitation and unified field theory in mind, and he wanted to discuss it with Feynman. Well, they talked for about 2 hours. I tell a more complete version of the story in Gravity Control with Present Technology, the book I wrote that's on sale on Amazon. But to cut right to the chase, Feynman encouraged him to publish it. So 7 years later, 1960, this is a pivotal date. He published The Origin of the Gravitational Force in the American Journal of Astronautics and Aeronautics. And he thought perhaps he could get a research grant to experiment with gravity. And simultaneously, the U.S. Air Force was interested in gravitation research, particularly in the idea of altering the gravitational field. Now, who knows exactly what motivated them, but for sure, it had something to do with the Soviet Union claiming at the time that they had conquered gravity and they had an anti-gravity aircraft that could get into space as easily as you would fly a jet plane. And because of the embarrassment of Sputnik, the U.S. Air Force was concerned about another embarrassment over gravity propulsion. So they conducted a survey, and the researcher who was in charge of the survey happened to live in San Francisco. We lived in Palo Alto at the time. So the researcher in charge got in touch with my dad, and they had lunch at Stickney's. Now, as I recall, I was present at that meeting. I remember 2 martinis and some very serious grown-up talk going on. And the researcher, his name was Dr. Maurice Garbel, and his final report is still available online, by the way. He told my dad off the record that my dad's theory of gravity was the only one he had seen dating from the time of Sir Isaac Newton that had any hope of an engineering application. Again, that was very encouraging. So next thing my dad knew, he was in a meeting with the U.S. Air Force at Ames Research in Sunnyvale. My dad worked at Lockheed. It was right down the road. And when he got into that meeting, it went south really fast. He was talking to what he described as a full bird colonel who was head of the Foreign Technology Division, which is an interesting thing. But the colonel told him that they wanted to sponsor a project based on his theory, a research project. And he also said, we want you to give us a timeline, how quickly you can produce a vehicle that will fly, something that will fly. And my dad said, that isn't the nature of research. You go in trying to find things out. You don't go in with a deadline and an engineering application in mind. And they said, well, we still want to back it. And my dad said, fine, that sounds good. And the colonel said, but there's a problem. You have a top secret clearance. We're going to have to classify this higher than the Manhattan Project, and you may not qualify for a clearance that high. And my dad kind of did a double take. And he said, what do you mean? You mean I might not be able to work on my own project? And they said, the colonel laughed and said, yeah, that's what it means. Now, my dad had experience with the Manhattan Project during the war years. He was not on the Manhattan Project. Coincidentally, however, my mom was, and it was kind of that way that they became acquainted. But my dad was working at the cyclotron, and by that time, Oppenheimer was head of the Manhattan Project, and my dad was doing experiments. And the Manhattan Project cast a shadow over everything. And the secrecy and the military use of science did not agree with him at all. And the idea that the military might take this eventual application and turn it to the use of weapons was too much for him. So he walked out of the meeting, said he didn't want anything to do with them. And the colonel's laughter was echoing in the hall, as my dad put it, as he exited the room. Well, flash forward now to about 1973. And my dad still doesn't know how to create anti-gravity. That was what he called it. I first became acquainted with the term when I was 8 years old because he had a study in the back of the house. And the moment he came home from work, he would go into that study and lock himself in until dinner time. And after dinner, he'd go back and lock himself in the study again. And the only thing he was working on was gravitation. He was doing research on paper that he hoped would eventually lead to technology in the sky above us. but he described the technology, the outcome he wanted for that technology to me as follows. He said he wanted to open the space frontier, Star Trek style. Star Trek, of course, wasn't around, but he had that same vision, kind of like who was the, okay, Jeremy, help me out. Who was the guy who invented warp drive?
Well, you're talking about Bradbury, Ray Bradbury. That was the guy who invented Star Wars, and then he created the characters. Zephyr Cochrane.
Zephyr Cochrane. That's it. Yeah, he kind of had a Zephyr Cochrane vision of what he wanted to accomplish. And this, by the way, I'm not just telling this anecdotally, it actually conditions another pivotal point that's coming up in 1981. Okay, 1973. This is now 13 years after the meeting with the Air Force, and nothing further was heard from them. We will hear from them again, though, in this story. Okay, so I found a book at Kepler's bookstore in Palo Alto, or Menlo Park, rather. It's called Ufology. That book is available online. The author's name is James McCampbell. Jim McCampbell became friends with my dad as a result of their mutual interest in UFOs. But there was a sighting recorded in that book that provided the trigger for his idea of how to create anti-gravity. That is not really a force that goes against gravity, but how to neutralize the gravitational field and the inertial effect in the vicinity of a vehicle. Because this is very clearly what the flying saucers, or if you want to use the politically correct term, unidentified aerial phenomena. Okay, it's a euphemism. Everybody knows what it is. And it's very clear.
It kind of goes from a slight truth to a complete untruth, because they're not unidentified, they're not flying, but they are an object. So they managed to take out the one piece of truth that's actually in there and make it a complete lie. It's unidentified aerial phenomena. It's none of those. It's identified. It's not flying. It's more like hovering, or there is some sort of shielding effect that's going on. And right. Definitely is an object.
Definitely is a material object, because they leave very deep landing marks when they touch down. And the burn marks from their takeoffs are also part of the evidence for them. But for the armed services in the Pentagon, the term UFOs is now tainted by the propaganda that they've been putting out since 1947 to ridicule the whole subject of UFOs. And well, I think they've taken a fresh look at their policy recently. Mark, you brought up the date, December 17th, 2017 or 2018, I guess. When
December 17th, 2017, that's when two things happened, supposedly. There was, according to Gaia and that guy, what was his name? The 20 and Backer, he claimed to have been on a spaceship that was near Saturn. And he was translating for an extraterrestrial named Ra-Ter-Er, which is like the ancient Egyptian god Ra. And the guy kind of like looks like Ra too, with the bird shape and everything. Yeah. And so this is like an other dimensional extraterrestrial, and he was translating into speech, going from telepathic communication to speech communication. And basically, they told the Super Federation, which are all these extraterrestrials that were involved here on Earth, that it's over. They have to stop their game, and Earth is now, have come of age. So, and the same date was when the New York Times released the ATIP article.
Right, with the gun sight photos from two Navy jets that encountered a UFO 110 miles west of San Diego. And well, to give you some idea, my dad used to travel around to White Sands Proving Ground and other rocket launch pads around the country in the 60s. And there he encountered a pilot who told him that he was regularly scrambled to take gun sight photos of UFOs whenever they launched a missile. They were as common as houseflies around missile launches. And so he had plenty of really, really good photographs, but the military was so, or Air Force was so secretive at that time that they would weigh him before and after he got off the jet fighter, and then they would take the photos, and they would tell him that if he ever leaked the information, he'd wind up in the desert. So, and they were very serious, very serious. He said they took me into a room every time I would go up, and there would be guards with M16s, and they would address me in no uncertain terms that this was secret and nobody was supposed to talk about it. Now, that was in the 60s. And so now it's okay because the Pentagon itself has released these movies. At first they said it was an accident, but now they've officially put their imprimatur of truth upon it. So they're preparing us for a change in consciousness about UFOs. But in case there are people in the audience right now who remain skeptical of the UFO phenomenon, everything that we're going to talk about in connection with my father's theory is hard science, and I mean connected to the mainstream of scientific development. It is this unified field theory, which did unite the four fundamental forces, is strictly a mainstream theory in the classical sense. And
yeah, interesting, David, that I've talked to several theoretical physicists who actually have come up with your father's theory on their own with their own physics knowledge, just using the tools and the toolbox that they were given from university physics. They came up with similar things to your dad. Which is interesting. And then when they found out about the experiment, when I've shown this to people, because it's not classified anymore, like you said, they're no longer bringing people out to the desert and killing them over this anymore. Now it's they rely on the amount of the disinformation, like that. The people going to Saturn and back and stuff like they flood so much disinformation out there that people don't find this stuff and they don't ever come across it. But even that's changing too, as you're mentioning now, like about the scientists. There are PhD scientists who watch my videos and in the audience. And at the last propulsion physics conference this past year, UFOs were actually quite a frequently mentioned topic. So the science community is no longer looking at this the same way as they used to back in the 60s, where it was once thought of as taboo and ridiculed and sort of shunned in scientific circles. I believe the time for that is changing, and if it's not, then it really needs to soon, because these things again, they are real. They do have physical characteristics as documented by NASA scientists like Dr. Paul Hill and others in his book Unidentified Flying Objects, or what is it? I got to get the book out. I have it here, but in any case. I want you to continue, but just don't feel like there are PhDs watching. There are PhDs who take this very seriously now, and if they don't, then they should. And if they're ridiculing
there are
this,
PhDs on the team. There are PhDs.
And the
we're
people
talking to me.
And the time for ridiculing this is over, David. So just talk freely and
give us the history. Give us the history.
Just give it to us straight. You know what I mean?
Oh. Okay, can I talk about the aliens in the White House? I mean, the reptilians. I'm sorry, I didn't want to insult anybody.
Good one, man.
Okay, let me go back. Let me segue from UFOs into my father's technology, because one thing that was very obvious, even back in the 70s, is that all of the sightings all over the world from observers who don't even know each other contain the same elements. For example, the vehicles have axial symmetry, like the flying saucer is a classic example of that. Axial symmetry is like a bicycle wheel, you got an axis and everything in the vehicle is an equidistant from the center of the axis. But so could a birthday cake pattern could do the same thing. A cylinder could do the same thing. But for some reason, they prefer this saucer shape. And I will come back to that in a moment. But this argues for a single technology behind the entire UFO phenomena. And my dad kept that in mind. And then came this book by Jim McCampbell. And there was a chapter, page 94, relates a sighting that the U.S. Air Force had over the Gulf of Mexico in 1957. And it was a bomber, just exactly like the bomber in Dr. Strangelove, but outfitted not for nuclear weapons, but electronic reconnaissance. And this plane was flying over the Gulf of Mexico with a crew on board that were getting training in electronic countermeasures. And lo and behold, out comes a UFO out of nowhere and starts flying rings around the aircraft. And they had their antenna, passive antenna, on, and they took readings from the UFO, and it was emitting a very strong pulsed microwave signal at a certain frequency. I guess it was 3 gigahertz roughly. And this started my dad thinking, what does a pulsed microwave signal have to do with their propulsion? So he went to a technical library the company he was working for at the time. That was Rockwell International. And by the way, in the interim, he had also worked at NASA in Houston and Lockheed Houston, and he was working on Earth resources satellites, where they would, look down on the Earth and try to find stuff. Anyway, that's another whole long story. I won't tell it here. Okay. And a book jumped off the shelf at him. I happen to have a copy of that book on my shelf, and if we were in the other room like we started out, I could pull it off the shelf and show it to you. But it was called Dynamic Nuclear Orientation by C.D. Jeffries, who was a professor at Berkeley.
By the way, that book is available online for free PDF. You could buy it for like $100, but it is free PDF. You just Google Dynamic Nuclear Orientation Jeffries. You'll find the book.
Yeah, and have fun reading it because it's almost completely equations, but it contains extremely valuable information for people who want to pursue this technology. So what it talks about is something that is not quite like nuclear magnetic resonance nor electronic spin resonance, because you're not electronic spin resonance is used in detectors at the airport to look at organic phenomena. But what you're doing is, in dynamic nuclear orientation, is you're leveraging the spin on the electrons and getting the electrons to flip the nuclei and add a directional movement to the nuclei. So it's a leveraging operation. The way it works is simply you set up a magnetic field that causes the electrons to precess in a uniform direction and around the same axis in a sample of a metal. And then you flash them at right angles with a microwave signal. This causes the electrons to precess so violently that they flip over. And when they do, they transfer angular momentum to the nuclei. And the angular momentum, the vehicle for that is the electromagnetic field. It is not, like tops, that kind of angular momentum, or like a bicycle. But in principle, it's the same thing. It's the magnetic moment of the electrons versus the magnetic moment of the nuclear particles. So anyway, this is a very good way to get the nuclear particles to orient. Now, what his theory led him to believe was that if you did this repetitively, say 600 times a second, it would deplete the energy in the surrounding gravitational field. Now, I can back up at this point and explain his theory in greater depth, but let's keep rolling. Let's just assume that this theory was worth testing and go into the deeper explanation at another time. Let's move forward to 1981. This was just a few years after he had this insight. he wrote a paper that was published for the Joint Propulsion Conference, 17th Joint Propulsion Conference in Colorado Springs, Colorado, home of the Tesla experimental station. And appropriately enough, I always thought. And his point in doing this was because he was announcing patentable technology. He thought, his patent attorney thought so too. In fact, they had filed a patent about 6 months earlier, and they were awaiting a verdict on it. His reason for doing that was that he was afraid that the military would clap a top secret classification or higher on his publication, and he would not be able to speak about it after that. My dad always respected secrets. There are things that he worked on I still don't know about, and I probably never will, but because he never talked about them. He always respected secrecy. But when he went to the 17th Joint Propulsion Conference, he turned what might have become a secret into a matter of the public record. And he wasn't afraid of losing his patent because he had already filed his patent. But the problem was, and became, the patent office turned down his patent without a comment. And his attorney was baffled by this because he was talking only about known technology. Dynamic nuclear orientation is known. All of the physical processes that he talked about in the 1981 paper were accepted by science. And yet they denied him the patent while granting the patent to numerous other anti-gravity devices which have never had a physical embodiment. So they demanded, I guess they demanded a physical embodiment, and at 1981, he didn't have the funds necessary to do that. So at that point, his technology became prior art, though Mark, I know, has another opinion. It's not patentable because it's a physical process, a natural process, and what it's like patenting an experiment.
But that's what happened with the Wright brothers, and there's a book on it. They filed for a patent for flaps or ailerons on an airplane. You can't build an airplane without ailerons. So what ended up happening? They tried to enforce their patent, and they eventually, one of them died of a heart attack related to the stress caused by fighting this stupid patent. And we almost lost World War I because of it, because no American company would dare build an airplane without ailerons. And the Wright brothers got the aileron patent, which was just retarded. So I don't believe there's anything that's patentable here until you actually build a craft.
Yes, and I think you're absolutely right. And I think what the way you've got to think of this technology in terms of generating income is twofold. Number one, when you see a Boeing 747 rolling down the runway, they do have patents on those Boeing parts, and probably 1,000 of them at least in a single plane. And when we create our first flying saucer, it's going to have patentable design parts. And that's the way it will generate money. But the technology is extraordinarily flexible. And the proof of it is in the skies already when you see birthday cakes flying around and flying saucers and spheres or orbs,
or pillars of fire and smoke that go and split the sea and confuse you into thinking they're God.
Yeah, right. Well, are you talking about Ezekiel? Are you going back then?
No, I'm talking about the splitting of the Red Sea, where
the splitting of the Red Sea,
where Jehovah got the Jews to think he was God, and until this day, the English Bible still calls him God. He's an alien. He's dead.
Well, yeah, you could find stories that entered mythology that seem to be explicable in terms of alien technology, just like you cite there. But okay, now we're into another gap. There was a 13-year gap between 1960 and 1973, and then 1981 comes along, and my dad is trying to get research grants to pursue his technology. Now, one of the predictions Dr. Garbell made in that meeting at Stickney's back in 1960 was that there wasn't a university in the world that would allow Fred's theory through the door. And the reason was it contradicted the general theory of relativity. If they did research on it, they would have to accept the possibility that it would be right, and then they would have to lose the general theory of relativity. By the way, the theory makes many of the same predictions that the general theory of relativity does. I don't have to go into that, but it's a comparable theory in its power. Anyway, now to people outside of academia, if you're not in academia, that sounds preposterous. It sounds like a conspiracy theory. Believe me, it is not at all preposterous. I have experienced it firsthand. The prejudice within academia toward anything that rocks the boat, as determined by the now accepted general theory of relativity, in which generations of professors have been trained, is anathema. They will not even talk to you about it. And in fact, I had one professor who was from Stanford who he was a Nobel Prize nominee in solid state physics. I lent him my father's paper on unified field theory, I guess that was a 1994 paper, published in Physics Essays. It's part of the bibliography in the book. Anyway, he kept it for a few weeks, and then I asked him, have you had a chance to look at the paper, at my dad's paper? I thought we'd have a nice rational discussion. We were sitting at a small table in South Palo Alto with 2 cups of coffee, and he went into his briefcase, he pulled out the paper, and he literally threw it at me saying, I don't have to read this paper. It's all bullshit. And that was an interestingly contradictory statement. He hadn't read it, but somehow he knew it was bullshit. Well, his explanation was that it contradicted the second law of thermodynamics, that he said, well, look at it this way. You could have a sack of potatoes that weighed 100 pounds, and using your anti-gravity device, you raise it 15 feet off the ground, and then you turn off the field, and it drops with kinetic force that is acquired by being raised into the air. And so it's impossible. And I pointed out to him, or I didn't point anything out to him, because he was so furious that there were, his spit was flying out of his mouth and hitting me in the face and on the table. And he was all red, and the veins were corded out on his neck. He looked like he was going to have a heart attack. And perhaps he would remember it differently, but I was there and I saw it. This matches my dad's description of his encounters with other professors, and in particular from Stanford.
You see that a lot in divorce court, when like one side says something true about the other, and they hate it so much.
Well, yeah. So I told my dad his objection to the unified field theory, and my dad said, well, your friend seems to have forgotten something about elementary physics. This is he's forgotten the difference between a closed system and an open system. He would be right if it was a closed system, but it's an open system, and you can exchange energy with the surroundings. That's all. So in about 1 sentence or 2 sentences, he dismissed this objection, which was the case every time a mainstream physicist raised any objections to his unified field theory. To put it in a kind of colloquial expression, they drew back a stump. They simply couldn't stand up to somebody who knew what they were talking about. And by the way, he did know the general theory of relativity at least as well as they did, probably a lot better. He was
trained under one of Einstein's proteges, right?
That was Victor Lenzen. Yeah, but also David Bohm and J. Robert Oppenheimer. And I think that they're responsible for his understanding of physical reality, which I'd be glad to go into later. It's really interesting because it simply extends an idea that's already fully accepted. It fully accepts the special theory of relativity, for example. But anyway, okay, so this is the kind of resistance his theory met. He decided finally that, and he made a grant application to the Department of Energy with the recommendation of Jim McCampbell, who was a personal friend of the head of the Department of Energy. So that was a That should have worked out. It didn't work out. Nothing worked. So in the end, in 1994, my dad wound up doing the experiment himself. This is the experiment that Mark is replicating here. And Mark may even be doing a better job of it than my father was able to do. And that's the invitation I made when I wrote the book. So what's that?
I hope so. I'm working very hard on it. We've had a lot of trouble. We'll get into that later.
Oh, great. Okay. Anyway, he knew that he was working with somewhat substandard equipment. So as he put it, he was seeking qualitative results, not quantitative. And so there were some measurements that were not taken that should have been taken that resulted in features of the experimental results that made them not publishable. I asked him after the experiment was done and he declared it a success, what was the problem with publishing it? And he said it would be ripped to pieces because I didn't have experimental controls like I should have, that I wasn't able to correlate the microwave pulses with the weight fluctuations. So there are flaws in the experiment. The experiment needs to be done better. But nevertheless, he thought it was a success because the readouts from the weight of the sample showed a pattern that he had predicted in his theory. And that pattern, if I could describe it to you, is a weight fluctuation that looks like, if I've got a pen here, I'll do it. Okay, blank piece of paper. Let's say your weight starts here. I'll pull back a little bit. Okay, good. Your weight goes up briefly, and then it goes down, and then it goes up again, and it goes down. Going up is the first part of the microwave pulse when the microwave pulse is driving the electrons, flipping them over. That intensifies the interaction between the sample and the gravitational field. So the weight goes up. But then you let go, you turn off the microwave pulse, and now the nuclei are all oriented according to the principles of dynamic nuclear orientation, and the gravitational field interacting with them at a subatomic scale is randomizing the internal electronic processes, which we call virtual processes. And in doing so, it loses some of its energy, and so the weight drops down. Then the microwave pulse hits again, and it goes up. The weight goes up, and then the microwave pulse switches off, and it descends further. See, it didn't recover all of its weight, so the second pulse drives it down further. And this is a cumulative effect. The cumulative effect has had a couple of implications for UFO flight, which I will go into later. Let me continue on with the experiment and its aftermath. So he thought the experiment was a success, and now it would be easy to get investors because he had a device. But they had set the device up in the basement of a university laboratory, and the head of the laboratory found out that some equipment was in the basement that should have been on the second floor. And he said, I don't know what you guys are doing down there, but you take it apart and return the equipment up to the second floor. So that deprived him of a $250,000 piece of equipment, which Mark has been able to replicate actually much more cheaply.
Oh, and yeah, we replicated it on I think it was like $250, and half of that was donated. But it's just the EPR magnet. That's what you needed.
Okay. So there was a big fight about money among the experimenters. The engineer quit and said he was going to do it himself. He never did it. To the best of my knowledge, so there was this period of a big letdown, but then my dad started trying to get investors based on the experimental report. And he talked to a lot of them. And at this time I was working in Silicon Valley, and I was going after investors. I spoke to Steve Jobs. I spoke to a number of millionaires and billionaires. None of them would do it until somebody else did it, or the technology got a endorsement from the likes of Michio Kaku or Neil deGrasse Tyson. And I very much doubt that either of those two celebrities would have given me the
We should
time
reach
of day.
out to him. Michio Kaku lives right here in New York City. This is like a half an hour drive. He could come down here and see what we're doing and, know if we're on the right path or not. I think, having a lab already set up that you only just need a couple more things to try and need a couple more minds, I think he'd be interested.
Well, I would love to invite him if you're open to it. My level of frustration with people at that level of celebrity just.
Jeremy, do you think we could get Michio Kaku on the channel?
I think. Well, first we got to convince myself and also all the other technicians in our group that like we have something like real, 100% authentic to show. And once we convince all of ourselves, then we're ready to bring it to other scientists, at that level. You know what I mean? I think like we've got enough people on our team now that we're bringing together, and including other people from the community that have watched what we're doing so far and have joined just to offer, the right expertise, because they see, oh, you guys are doing good work, but you're missing this. And because I'm an expert in X, Y, and Z, I can help you. And I'm going to, and we've
got a lot of anonymous people suddenly contacting us that know the specific field that we're looking for. Right. There's a couple pieces to the puzzle that we're not 100% sure about.
Right, and absolutely, we're gonna run into that, and I want to encourage anyone out there: don't be afraid. Reach out, reach forward. No, the government's not going to come after you. You're not going to wind up in the desert. We're just trying. For all we know, this stuff might not even work, and or it might it. For what I think is that this is a bridge into a lot of other things, and I'm trying to, people are going to pick out the important parts of this, and I'm going to pick out the important parts of what I think is important, and put a summary together afterwards, but people are already paying attention to certain key details, and like Mark said before, these might be details that David isn't even aware of yet. They're just little things, parts of the story that he may not even realize are significant, but so let's get. I want to continue with this story a little bit. Dave, I have a couple questions for you.
Sure, fire away.
This Ames research place that your dad did was brought to first.
Yeah.
Is that the one that's Ames research related to NASA, the Ames Research Center for NASA?
I believe it is. Yeah, it's NASA/Ames Research.
Okay.
In Sunnyvale. You can look it up online. I don't know if it had the same title in 1960, but my dad worked at the same facility, and it was on his resume. I think I published his resume or his CV in the book. I'm not entirely sure. As I said to Mark, I don't even own a copy of my book right now. I sent away for some copies after our last conversation, but they aren't here right now. I have the digital file, but it's on the other computer, and that's in the other room. So anyway, NASA.
I'll have to get you to sign me a couple copies, and we'll auction them off for funds to buy some of this equipment that we're doing to run this experiment.
Sure, I'm getting some copies in the mail. Very soon, I'll autograph 3 of them and send them to you, and then we can go for some more.
We could auction those off and try to make some money. Right now, the main piece of equipment that we'd need if we wanted to go on to the high power version of this test is a new signal generator. Like the one I have over here is just not always putting out a signal.
Uh-oh.
It's in a very tight range too. And we're going to go with the Thyratron, which is in the C-band. And we could have weaker magnetic fields in the C-band. So it's actually more useful if we wanted to make a full-size craft. And it's also 3,500 watts. So like we could really pump that Faraday cage with energy.
Okay.
That signal generator is probably around $3,000-$4,000 to get a decent one.
So why don't we shift gears now? Do we think we covered David, do you think we've covered enough of the history? Is there anything more that you want to add on the history? Because I want to shift gears soon and start getting into the experiments.
Okay, yes, I do. But let me conclude the story and bring us up to the present day. There was a long period after the experiments when we tried and tried and tried to get investors. And I was working in Silicon Valley to get investors. And then in 2012, my dad at that time was 93 years old. He passed away. And at that point, I realized that nothing would be done unless I did it. So, you know, like the little red hen, I went running around. First place I went to was my former alma mater, UC Santa Barbara, where my dad had actually worked in the physics department. And they would not even give me the time of day. This is the book as written by Dr. Maurice Garbel. They wouldn't give me the time of day in spite of the fact that I was a graduate of UCSB and that my father had worked in the physics department, Santa Barbara Research Center. And so then I thought, well, this must be some kind of an anomaly. So I started going around to all the universities. My first goal was to get a university lab to do this experiment right. And I thought the prospect of a Nobel Prize and zillions of dollars in grants would interest them. But it was not enough to interest them in contradicting the core doctrine of general relativity. So at that point, I just gave up on them, and I went to the civilian space agencies. You name it, I talked to them. Well, except I didn't talk to them because they wouldn't talk to me. I sent them letters to initiate a conversation. Never heard back from any of them. This was pretty much the same thing we experienced while Fred was alive. Well, okay, I gave up on them and I decided, what's left? Okay, Hollywood. I came up with an idea for a TV show. We would redo the experiment, and this would be the cliffhanger that would keep us going through 6 episodes or whatever it took, and the production company would front the money for the experiment. They too were not interested. So I decided finally to write the books, and that's why the books were written. Never dreamed of making much money on the books, I want to tell you, and I was just essentially giving everything away because any financial interest I might have had in the technology, I had to be willing to sacrifice that too. And my hope was, and now here comes the punchline, my hope was that independent electrical engineers would carry the torch over the finish line for my dad, because
this is your dad's torch, actually. Literally, this is the thyratron from UC Berkeley that they used to discover americium and berkelium. So we're carrying your torch. I bought 2 of them, actually.
Quite literally. So the point of my telling this long story is to inspire not only Mark, but other engineers who might feel they could do this experiment. And the goal really is to get more than one group of experimenters to successfully duplicate the experiment and prove to the scientific community that the idea has merit. For example, if only one experimenter has a successful result, well, who knows, maybe that was an anomaly of some kind, that was a freak, there were other forces involved. But if multiple experimenters do it, it's going to be a revolution. And
we got both torches here. This is part of the accelerator from UC Berkeley where your dad worked.
Now you use the word accelerator. This technology will accelerate the progress of humanity 100-fold into the future and enable us to get into space and start actually exploiting space for all kinds of resources and industrial production, waste disposal. We can send things into the sun and have them vaporized.
By the way, David, I didn't buy this because your dad worked on it. I bought it because I needed it.
Oh, okay, good.
I didn't know that your dad used it at the time. I bought it. Actually, I didn't even know of your name at the time. I bought this to try another experiment, which involves hitting parallel plate capacitors with a ton of energy. We haven't tried it yet, but I got the part. And this is something that we needed. And
so let me say one last thought. if this experiment is a success, if it is, if it attracts the kind of attention that I hope it will, or if this experiment is a failure and somebody else manages to do it for whatever reason, then we will see the annual output of the industrial output of the world double within 10 years. Double. And dreams that were only science fiction dreams for all of us growing up will come true. Voyage to Mars, easily done. Instead of, what is it, $250,000 a ticket to go into suborbit, it'll be a nominal price to go to the moon or Mars or any destination in the solar system you want to go to.
The crazy thing is it'll probably change prices different times a year because of the distance to Mars.
Right.
Right now, we'd get very cheap tickets. We're coming in on the perihelion, where we're the closest to Mars in the past 2 years. It's happening in 2 weeks.
It will also get rid of external controls on aircraft, rudders and stuff. Like we said, with this technology, to do away with a lot of that stuff. And it's going to revolutionize a lot of industries, which is why so many people are afraid of it, because it's going to put a lot of people out of business and a lot of industries that are currently
let's say industries. Not. It will not destroy businesses. It will transform them. For example, I want to mention big oil. Big oil has a huge problem, and that is peak oil. And also, not to mention the pollution problems, which they're regularly blamed for and they regularly deny, but it's becoming all too obvious that fossil fuel is going to destroy us. Well, here's a way for them to actually raise their profit level by going into space-based mining and other industries, transforming the wealth they've accumulated into space-based industries, and the pressure's off to produce fossil fuel, which is getting harder and harder to find. So it's a transformation.
I absolutely agree, David. I just want to give a quick shout out to two members of our audience. We got Rather Be Squidding, gave a $5 super chat, and Ryan Hedgem gave a $20 super chat towards research and experimentation. You guys are awesome. Just for that, you're gonna actually set off some stuff in the background here. Look at our science experiment here in the background. Oh no. Oh geez, we're filling up fast.
Wait a minute, is that alcoholic? I'd like some if it is.
Yeah, no, it's about to be.
Okay.
So, I didn't have it plugged in. Sorry, I just spilled it everywhere. You guys caused an overflow. If we keep getting donations, we might have a reactor core meltdown. Anyways, thank you. That's appreciated, and we got lots of stuff going on in the lab. So thanks for that.
Now, I know I've monopolized airtime for a long time, so why don't you guys take it away?
Yeah, I have some questions as well for you, and I want to get more into the nuts and bolts of the experiment and how it was done, and some of the also some of the things you pointed out that you had mentioned that were tried that we talked about. So one of the things that was brought up by a member of the chat, Fail Forward Research, asked about temperature change in the samples, and that some of these samples, when they're you're hit. Is it just heating up because of the microwaves you're hitting it with, or is there's other is there any significance to this temperature change? Because
yes, there is a significance to the temperature change because the decay and orientation becomes progressively shorter the higher the temperature. You want to keep the sample down around room temperature in order to experience the effect. Most experiments in dynamic nuclear orientation have taken place near absolute zero. But it is possible with a very pure isotope of aluminum or sample of aluminum up in the 99.999% range to prolong orientation at room temperature up to 0.06 seconds. I'm getting turned on.
That's enough nines, right?
Huh?
Is that enough nines?
That's enough nines. I know those nines are hard to buy. Every extra nine costs a lot of money. Excellent.
We got 5 nines. These little pellets.
Wow. Super. So the material you use and the temperature of the material matters quite a bit. And I do believe, and Mark has also, we've talked about this off camera here, that the alien craft are using very sophisticated technology to prolong the orientation in the shell of the craft. And possibly what they're doing is constructing the shell out of layers of material that somehow resonate with the frequency that they're using to defeat the gravitational field to prolong the orientation of the material in the matrix. And I'm sure, you know, with thousands of years to work on this technology, that they've gotten so sophisticated at it, we can only dream of it. But in principle, we should be able to do what they're doing.
Right, right. People don't realize how far we've come and how important frequency and orientation and all these different energies are to what we are, to what our matter, what inertial mass actually is. Like, we are matter and matter is energy. And you can use energy to manipulate matter to make it no longer have this inertial mass, you know, that going on, because it's the randomness that allows us, that gives us the inertial mass in the first place. If we were able to orient it, we get rid of that.
Well, Einstein announced the equivalency principle as part of the general theory of relativity, and that was the equivalency of inertial mass and gravitational mass. And so there's long been recognized a relationship almost directly proportional between mass and inertia. And so if you have a process, a anti-gravity process, or as my dad liked to call it, gravity control, he found out you can't say anti-gravity without discrediting yourself. So he started to call it gravity control in 1981. Then you should be affecting the inertial mass too, and that does fit into his theory. When you have a vehicle that has zero interaction with the Earth's gravitational field, it will also cancel the inertial mass of that vehicle, 100%, or pretty close to it. Say the sample is 99.999. That's about how much of the inertial mass will be canceled when you get the vehicle fully charged with the effect. Okay, so I hope I answered that one.
You also mentioned that your dad told you of another way of doing it. Instead of hitting it with the RF, you just spin the sample around?
Yes, we had an interesting revelation in one of our earlier calls about another idea my dad had, which I just mentioned out of the blue. He thought that you could have an aluminum wheel or disc or flywheel, and you would spin it, and this would orient the electrons. And then Mark told me that this blue area inside of this diagram was a spinning disc. And I don't know is it aluminum? Or?
Yeah, it's a spinning disc. It's an aluminum flywheel in the center of an electromagnet.
So it's
exactly what your dad said.
Super coincidence out of nowhere. And I did not know about this. Well, I'd seen pictures of the vehicle, but I'd not seen the parts labeled. So this was news to me. My dad took one look at this diagram and said the green area that you're looking at there is a capacitor, and it's to create the pulsed microwaves in the shell of the craft. Now, this is the vehicle that apparently that the Air Force had reverse engineered from the 47 Roswell crash, and it was flying in 1954, but it wasn't flying very well. And I think that the Air Force interest in my dad's theory might have been in order to get a theory that would match the technology that they had been able to reverse engineer from the alien craft. And that's what they got, but they didn't get it until 1981. Now, after the 1981 paper, I have it from a apocryphal source, somebody who I met at a UFO convention. I don't know his identity. He had a name badge that was flipped over. And he said, "Oh, are you David Alzofon?" And I said, well, yeah, and you're related to Frederick Alzofon. I said, I'm his son. He said, oh, say, did you know that you remember 1981, the paper that he wrote back then? And of course I knew that. He knew that. There's the paper. And he said, yeah, the CIA, did you know that the CIA hired 17 mathematicians to go over that paper and check every equation? And all of your dad's equations were correct. And then as that was sinking in, he said, yeah, there's the vehicle he said would work. I don't think he wanted to draw a saucer, but that's another form.
I saw on Facebook a picture of this craft actually flying. They actually built one like this.
Yeah.
Oh, God.
Yes.
There's another one I didn't know.
Yes.
Well, anyway, I don't know exactly where that drawing came from, but it was 1981, and I think that my dad drew it with drafting tools, but I don't think he copied it from anywhere, or he would have told me about it.
Or maybe they actually went and built it because that's what was in the paper.
Well, that could be too. Well,
maybe your dad designed it and they built it without even telling him.
Well, it definitely would work.
I'll have to send you the link to that picture. It was posted on one of the UFO chats on Facebook.
Yeah, well, somebody read that paper and then made up a hoax to go along with it. I don't know.
That could be.
So, in any case, I wanted to ask about this. What was it? They had a question in here before that people were asking about. It was just. Oh yeah, I wanted to talk about just the resistance to new ideas within the scientific community and stuff in general. Like your dad's story sounds so much similar to the Thomas Townsend Brown story, as you know, people have been talking to his daughter. His daughter came out recently. We've got I have a bunch of friends who've been in contact with her and talked to her. You know, and basically her dad's research, he discovered this effect in the 1920s called the Biefeld-Brown effect. Of course, it's called the Biefeld-Brown. It's really, I call it the Townsend-Brown effect because he just got a physics professor named Biefeld to help him write the first paper on it so that he could get a paper published for just to have something. But Biefeld quickly, shied away from the research and fell back into the, the mainstream, Catholic Church way of, modern Catholic Church, wasn't afraid to be a heretic and an outspoken critic of, the mainstream science at the time. But Thomas Townsend Brown continued like his kind of research into this stuff and even trying to approach the military and trying to sell his idea of this gravitator and some of this technology to the military. Of course, they had basically said that because he was so mainstream, like that he couldn't be given a security clearance and couldn't be granted anything. So they basically had to like rebuff him and convince him he was insane and that there was nothing to this, while they carried on his research in private with using other scientists and other researchers. It's kind of telling kind of like a historical tale of how the secrecy pervades and how the secrecy takes, how they mentioned your father was classified higher than the Manhattan Project. I think
that's what the man said. Yeah,
that's very significant, and it's related directly to Thomas Townsend Brown's research, and the things that his daughter described about, what her father experienced, trying to bring this to the military, getting shut down, telling that he's crazy and that it's not working. Meanwhile, they shut down all these lab experiments of these people that were discovering it on their own, and that they would shut them down and pay them to say that the results failed or give false report on different things. Well, meanwhile, they carry on the research continuously underground, and the Biefeld-Brown actually led to the development of the X-1 plane that broke the sound barrier with Chuck Yeager by ionizing the nose cone of the craft to it actually reduces the speed of sound in the ionized area of the ionized gas in the front of the craft, so that they're allowed to break. It reduces the bow shock on the front of the craft, and they're allowed to break the sound barrier. Very interesting stuff that we're now finding out, and then it's of course leading to the doing away with those external controls over the aircraft. Now you can basically use microwaves on the leading wing edges to ionize the air in different ways around the craft to make the air bend around the craft in different ways, and you can even use it.
They're actually talking about that was high voltage at the peak of the airplane in order to ionize it and make it more more fluid for the aerodynamics.
Right, but they heat it up. It opens it up. It opens it up. So like
it opens it up to allow it to go through. But that's the high voltage that's doing that. They're not using RF. They can't.
Right. This is different. I want to distinguish that this technology, the Biefeld-Brown effect, is not a gravitational effect. It's
actually a thrust, and that's what I think is actually going on over here. I think your dad was wrong about the parallel plate capacitors in the base. I think his experiment is actually going on in the center, because they weren't using any RF for this. Otherwise, they would have cooked the occupants. What they're doing here is they're using that to negate the inertial mass as best as possible. And the parallel plates capacitors in the base are being pulsed in order to create the thrust necessary to now move this craft that is now 99.9% destroyed. That it only weighs 0.1% of its original weight.
Yeah, because that blue shielding area would be a lot larger if that were the case. If that whole green area were producing, that blue area would have to be a lot larger. So I think you're right.
Yes, but there is a this effect actually does spread to surrounding materials.
Yes, I'd like to interject a word here about that. The nuclear orientation is contagious. So if you have a central core that's flashing the hull with microwaves, it doesn't have to reach the whole body of the craft equally, because the effect itself will bleed out from the center and eventually reach every corner of the craft. So I can't point to parts of it, but let's say you had a waveguide in the center of that object that you're holding up before the screen, and you were flashing the microwave signal around the interior, cooking the pilot and so co-pilot. But let's just say this is a drone, so you can do that. Then you would be creating dynamic nuclear orientation in the top of the craft, but it would eventually bleed out to the entire craft, and then you would have a weightless vehicle.
So basically, this is the source of the nuclear orientation, and it sort of creates a nuclear orientation magnet that goes out and orients the entire craft as much as possible. You're not going to achieve 100% here, but that's why we have the parallel plates in the base. They're being pulsed in order to create, the couple pounds of thrust that it then takes to control the craft. And there's a little ball over here that controls which parallel plates got pulsed. And the tanks, that's for the hydrogen fuel cells that power this whole thing. And this was the control arm to get samples from Mars and whatever.
Yeah. That's great. Now, the way this thing flew, as I heard it, was that it tended to hop like a grasshopper. Do you have any ideas about why it might have done that?
Probably because when it was close to the ground, it weighed so much that it needed to pulse all of them in order to get off the ground. That's probably why. But this was built in 1956, and I think it's a crime against humanity that we're still driving around in gasoline guzzling cars.
Yeah. Now, let me just mention that the price of an anti-gravity vehicle would eventually come down out of the stratosphere to about the price of an SUV, because there are very few moving parts. It's all electronic. It's like an extension of the Silicon Valley revolution into space and into aviation, civil aviation. A vehicle is going to be cheap.
Yeah. And it's going to also take over airplanes as well. Oh, yeah. There is one issue that I wanted to bring up, and that is if you're going to have microwave radiation being emitted by these craft, it's not something that you're going to land in your backyard. You're going to need spaceports that are probably going to be like Faraday cages that you go into, and there's, you have a Faraday cage in order to get into the craft, and then it takes off. It's not going to be something that you have in your garage and you're flying around, here in New Jersey like that.
Well,
electric cars are still going to be a thing.
I think we should ask the aliens about that, because they've been observed to be hovering over people and neighborhoods. Now, sometimes you do see microwave discharge that is harmful to the people who are observing the UFO. And but in other cases, you don't. And I'm not sure exactly why, but I think that spinning
it
disk
sounds to me like losses or leakage in the system. Like the idea behind this, like as you mentioned, you said it starts as a wave in this one spot, and then it vibrates out locally from that area. That screams coherent states at me, and that coherent states of matter. And if there's too much damping in the material, too much damping in these effects, then you're not going to get those coherent states to spread out from that one spot and spread over the whole surface of the craft. And that goes back to, again, what you said about why they're shaped like saucers or bells. Why is a bell shaped like a bell? Oh, because that was the most resonant shape that they could think of, that they could create an object that they created a bell in the shape of a bell for resonance. Why is these flying saucers also in the shape of a bell? Because of resonance. Because when you have this type of resonance, you have this lossless effect, this lossless transmission of those waves. Again, the propagation where there's less dampening, and there's less of those effects that cause the losses. And that's again, when I'm thinking microwave radiation that's leaking away from my craft and is causing danger to my surrounding environment, I'm thinking that you're having too much loss in whatever your propulsion system is, that you're not, you just need to be more efficient.
Yeah, I definitely agree with that.
There's another little anecdote I want to interject about flying saucers. And that was always a big mystery. How do they stay up in the air, and why are they shaped like a saucer? And this was used to ridicule the idea that there was any reality to the phenomenon. It didn't conform to our ideas of aerodynamics. But now we can see that it's a perfect design aerodynamically. The way my dad described it was, one day I went into his office up in Oregon, and he said, take that book off the shelf and take a look at page 726. And I opened it up, and there was a diagram on that page of a perfect radar antenna, which was shaped basically like a bowl. He said, does it look familiar? I said, no. Well, it's a radar antenna. We used to see those at Stanford. And he said, well, looks like half of a flying saucer, doesn't it? And suddenly it hit me. What you have with a flying saucer is a bowl facing a bowl, and both of them are ideal radar antennas. And this minimizes the amount of energy that you have to put out to get dynamic nuclear orientation in the hull of the craft. So it's the perfect design. Two bowls facing each other, two radar antennae facing each other. And well, anyway, that's why we see the saucer shape used over and over again. It's efficient. As for the means of, yes, sorry.
So I just want to make a mathematical statement to extend on that point of parabolic antennas, so people know. Parabolic antenna is actually the shape of the antenna is made with the x squared curve, the graph of x squared, y equals x squared. And it's made so that every point reflects equally from the focal point F, so that it straightens out all the lines and makes them all straight and lines them all up. So they, if you had two of these on top, then those lines would be bouncing top and bottom, going straight and top and down. They'd all be perfectly aligned because of the mathematics of it.
The UFO shape and the UFO flight characteristics are an indirect support to the theory that my father came up with and the technology, because his technology explains all of these effects that have been observed ever since people started observing UFOs, and gives them a unified explanation. And before, there was no coherent picture of, for example, why They take off from the ground with the help of a rocket and then wobble insanely like a dinner plate on a tabletop, and they get steady and take off like a bullet, or why they tend to fly in a sinusoidal flight path like this. All of that is explicable in terms of the theory. For example, the sinusoidal flight path corresponds to this chart that I drew here. As the power builds up, the craft gets heavier and it begins to fall. And then the microwave field is released, it begins to get lighter, and when it becomes lighter than air, of course, it's going to rise up like strictly on the basis of flotation. And then this is going to cause, as the power fluctuates, the sinusoidal flight path. Power fluctuation being a characteristic of the gravity reduction method. So there's an indirect proof. Also, the falling leaf pattern is also based on this. When a saucer approaches the ground, they sometimes exhibit this falling leaf pattern, zigzagging to the ground. I go into a lot of detail about that in my other book, the Top 10 UFO Riddles. Book plug, but the crop circle phenomenon is part of it. The Neil deGrasse Tyson, let's mention him. He did a radio broadcast in which he said only stupid aliens would design a flying saucer because they spin like this, and that's a waste of energy. Actually, it's a side effect of the propulsion system. When you get a gazillion electrons precessing in the same orbit like this, it's going to cause the saucer to spin slowly. And you can duplicate this effect in your bathtub. You could take a gigantic pie plate that you get from Walmart for $2. You put a couple of gyroscopes on it, and as the gyroscopes precess, the plate will turn like this as it's floating on the bathtub. And you'll say to yourself, whoa, that's alien technology in my bathtub.
I always described it as like if I took a quarter and spun it, that motion that it does right before it hits the table, like right as it's lowering its spin right like at the bottom. You know, it's only where only one edge of the coin is touching the table at a given time.
Right. You know. Yeah. I think that's due to the uneven distribution of weight spiraling around the craft during the power up phase of the launch. It's getting off as its weight gets
super interesting.
Yeah, the weight isn't distributed equally until the vehicle is 100% charged. At that point, it's going to stop rotating. Well, you can stop it from rotating other ways, but it's going to stop precessing like a top and get steady. And at that point, they can shoot off at any speed they want to. That's been observed lots of times.
Yeah, I was also wondering about that. Like, if you have so much spin going on, is there a point where you have too much spin and you got to like spin something in the other direction to cancel it out? Like have a spin ballast kind of system?
Yeah, I don't know what they use for that, but you could use a
How about water? Just use the water that comes out of the hydrogen fuel cell as your spin ballast system.
Sure, or compressed air. It doesn't take a lot to stop that spin because the vehicle.
That's only when you're in the atmosphere, though.
Yeah. Compressed air.
Mm-hmm.
Could you do that in space too? I don't know.
Yeah, I guess so. But I'm talking about not losing any mass from the craft. So what you do is you would have at the very edge of the craft, you'd have a spin ballast, and you'd fill it with water, which is a byproduct of the fuel cell. And then you just spin it in the opposite direction when you build up too much spin. And then by the time you land, you know, when you touch down on the ground, you'll turn off your ballast by stopping the the spin, and you'll transfer that energy to the ground so that you can restart the system.
Well, these are interesting engineering questions that once the basic technology is firmly established, you could start doing experiments to eliminate the spin and the wobble and everything else. You know, who knows what the final embodiment of the technology will be, but lots of different ways to do it. Now, you know, we got at least 2 ways to create.
I'm super excited about mining the asteroid belt. I don't know why, but I have an itch to try that. It's like more exciting than going to the moon. I want to go to the asteroid belt and bring back a hunk of metal and have a company, you know, drop it on a factory in China and have them turn it into something. Or you know what? I'll mine some nickel for Tesla. How about that? We go out to the asteroid belt and grab them an entire asteroid so that they can make their batteries.
There was an asteroid that passed by the Earth in, I think it was 2018, that was made almost completely of platinum. And unfortunately, there wasn't any civilian space agency that could go grab some of that platinum because we just didn't have this maneuverability in space to do that.
The money is in the space mining because right now we're destroying, and it's also the biggest environmental disaster here on Earth, that we're destroying our planet looking for minerals that are available in space in their purest form just for the taking. All you have to do is go out there and grab it and bring it back. That's all you have to do.
I agree. We just need more maneuverability in space and better technology for getting around in space. And that is what I believe all these technologies are unlocking. Did you guys know that, I think it was Bloomberg, Israeli military tech firm. I'm bringing this up on screen right now so that other people can see it. I'll send you guys a link. But this was on Bloomberg.com in technology today. Israel military firm seeks $200 million for startups.
I got some connections in Israel. I'm Israeli.
Right. So it's interesting. Well, you know, when you see business getting involved, it always makes me a little you know, questionable and nervous because but it also gives me this sort of gives me a little bit of reassurance because you're talking about all these ex-Israeli defense people taking newly declassified technology and they're trying to apply it for commercialized purposes for the aerospace tech that's coming out. So they know that aerospace tech is coming out to the public. Okay, hint, wink, wink. And they're trying to basically capitalize on it and set up firms to, you know, create commercial markets for this technology. You know, so when you see stuff like this coming out, it's just more verification of that, you know, the business sector and as well as intelligence are already aware that this technology is working its way out to the public, and there's nothing that they can do to stop it.
Yeah,
we could use some of that money. I mean, I think what I could do with $100 grand is, you know, what they could do with 10 million. Because we don't have any salaries over here. Everyone who works for this is so passionate about what they do that they don't need a salary. And we have the top minds in this entire industry working on this right now.
Yeah, as far as the human resources level, to go and recruit people that are into this, I mean, you could recruit some really good scientists out there. I'm sure there's some talent out there that we've yet to recruit and bring on board with our team. But no one's been doing this quite as long as I have, at least not publicly, out in the open sphere, as long as some of the people in our group. And I've really brought a lot of people together and involved a lot of people, you know, getting more.
That's what you've been.
That's what I am. I'm the guy as I put people together. So people want to get involved, they email me, thealienscientist@gmail.com, guys, and get in touch with me. And I'm basically the connector. I'm the networker. And if you want to be part of the network and you have the skills and stuff, I'm the human resources coordinator. And we've already got the team, we've already got the laboratory, and we've got the setup, and now we're talking to the people out here live. David Alzofon, man, thank you so much for joining me. Your story is amazing of what you told me about your experience and your father's experience in what he's done with this technology. just tell me a little bit more. I want to know just what it was like being his son, and just how he was as a father.
Well, I will tell you that he had a dedication to physics that was the equivalent, roughly, in my opinion, of the dedication of a monk to religion, because I never saw him spend less than 6 hours a day reading physics books or going to the university library and studying the latest in the physics journals. He loved science, but he was also he was equally interested in benefiting humanity. Now, given this combination of characteristics, is selfless dedication to science and the very profound desire that whatever he did in science should benefit all of humanity, you would think he was something of a saint, but he could be very difficult to get along with. He could be extraordinarily difficult to get along with. But I will say that everybody in our family loved my dad a great deal. And my brother has chosen a career in science because of the influence of my father.
Which is interesting because sorry to interrupt. You do guitar, but we'll get to that in a second.
Yeah, I'm a guitarist. Well, look at how hard I've worked on behalf of my father's ideas too. I was kind of afraid that if I started in that direction, it would completely consume me, and I wanted to establish my own identity. But somehow I wound up spending a good deal of my life, particularly in the 8 years since my dad died, working on almost nothing but his technology, trying to interest the world in carrying it forward, because he wasn't recognized within the scientific community for this. He was recognized for other things, because he was recognized as a world-class authority in optics and also in the Sommerfeld method, which is a way of analyzing radiation dispersion and diffraction. He extended Sommerfeld's work, which is famous, but it was regarded as limited, from a half plane to objects of arbitrary shape. Now, you think, well, that's very academic, but what are objects of arbitrary shape? Well, they might be, say, an airplane, or they might be a snowflake. It might be used for improving radar imaging. It might be used for improving the functioning of DVDs and CDs and all kinds of electronic stuff. And he managed to do that in closed form equations, which means no infinities, exact solutions. So you'll find a book called Exact Solutions to Diffraction Problems by Frederick Alzofon on Amazon. It's very, very technical, like most everything else he wrote. There was a book he wrote for Lockheed that was on multiple universes. This was all based on the experiments he did at Cal on the cyclotron. He observed anomalies in the collapsing electromagnetic fields that he thought could only be explained by an alternative universe theory. So he wrote a book about it, and he got it published by Lockheed, but it wasn't exactly a bestseller. I managed to get my hands on a copy of it just recently, and I'm hoping that I'll be able to make a PDF of it and resell it on Amazon to support further research into the gravity method. But it was a very, very thick book, huge. Anyway, so what was it like growing up with my dad? Well, I gave you kind of a glimpse of it. He used to come home from work and go directly to his study, lock the door, and he used to not come out until dinner, and then he'd go right back in again. There were a couple of exceptions. He would watch Perry Mason with us. He would watch some Saturday morning cartoons. He loved Walt Disney and cartoons, and he had a kind of a fantasy side of his personality. He had 4 bookshelves completely filled with science fiction magazines dating back to the 1930s, every single issue in a series. and that's because he never missed an issue. And I think he always dreamed of being a science fiction writer, but uh, he just never found the time for that. Um, what else could I say? Okay, so he seemed very distant from all of us. That was a hard bridge to gap. But he talked to all of us like adults when we were little tiny kids. But then he could be goofy too. We would have liked more goofiness from him, but he was a very, very serious person. Now, in his neighborhood in Oregon, he was very, everybody liked him because he'd come to the barbecue parties and entertain everybody with stories and jokes. And he had a wry sense of humor, very wry sense of humor. And I don't know what else I could say. He didn't like exercising much, but for some reason he lived to be 93. They told him when he was 30 that he was going to die by the time he was, no, they told him when he was draft age, he was 4F because he had a heart murmur. And they told him he was going to be dead by the time he was 33. And he lived to be 93. He just defied convention in every single way. And what else could I say? Okay, here's another thing I noticed about my dad. When I get into phone conversations with him, I never knew what he was going to say next. He continually surprised me. And it wasn't just that he seemed to read more than most people by tenfold. It was that he would put all of his knowledge together into patterns, and he would see these hidden patterns and everything. So I always liked talking to him and listening to his stories about movies that he had seen and what he thought of the movies. And he was a big fan of the movies. He worked in Hollywood when he was going to UCLA. He worked in a prop shop, and he used to tell me about how he saw Clark Gable kissing, who was the leading lady opposite Clark Gable. I saw her kiss. He saw the two of them kissing on the sidewalk right outside his store there. He had a lot of Hollywood stories. So he was a great storyteller. And yeah, we all miss him. It's a terrible thing. I wish he could have lived to be 203 instead of 93, but such is life, you know.
Did he keep it all the way to the end?
Yes, he was working on papers on physics. He was publishing papers on physics up until the very end, about 1 month before he died. And what happened was he was exposed to a lot of radiation throughout his career. I won't say it was just the cyclotron. It was other things too, but they weren't as careful.
Responsible.
Yeah.
This is what killed your dad. His torch.
Okay, smash it.
No, we're going to use it for an experiment.
Revenge is sweet, no matter how much delay.
Yeah.
So it's kind of interesting how you back to you chose a career as a musician. You play guitar professionally and stuff.
Well, I worked for Guitar Player magazine. I've written a book about guitar, and I wrote a book on composition called Compose Yourself. And I got as interested in music as I think my dad did in science. And my degree actually is in fine art, and I just didn't pursue it. And then I've been a writer. Professionally, I've been a writer ever since I got out of school. And I'm grateful for that because I don't think the book would have turned out as well had I not been a writer. So it turned out to be a happy
I'll let you in on a little secret. While you were trying to get your computer restarted, me and Jeremy went live and we were having a jam.
Oh,
we didn't go live with the jam.
I play the flute and Jeremy plays guitar.
Oh.
Yeah, I play guitar too, man. We'll have to all get together.
What kind of guitar do you have, Jeremy? Or
I have two.
What's your favorite?
I have two acoustic guitars, and I have two Ibanez electric guitars. One with active pickups and a Floyd Rose, and one with just regular pickups and passive pickups and no Floyd Rose. but I don't know. I play guitar, and but I've been more into like vocals and singing and stuff.
Cool.
But I wanted to point out that I gotta find. I'm trying to find him right now. So I'll get back to this in a second. But go on and tell us more about how did you get into like why did you get into like music as opposed to like your dad's a physicist and you got into
Because
music?
I loved music growing up. I was glued to the radio listening to the top 40 from the time I was a little kid. And my dad had a violin. He was a musician for a while, but he gave it up. But I've discovered his violin in the closet, and I asked him to play the violin for me, and something just told me I have to learn how to do this. It was one of those life-changing experiences. And for all I can remember, he only played a couple of notes. He felt very badly about having to give up the violin. But to me, it was the most beautiful thing to imagine playing a musical instrument. So I kept practicing. And when I was in high school, the Beatles hit. And then that convinced me I wanted to study music theory and learn how to write songs. So I went to school, got a degree, and then I went back to school and studied music, and I started writing freelance for Guitar Player magazine. I worked for a jazz guitarist named Howard Roberts. You may have heard of him. He was a member of the Wrecking Crew that was the subject of a recent movie. Fantastic guitarist. And then eventually I wrote a book on how to play guitar. And then I went to work for Guitar Player magazine. And right across the street from Guitar Player magazine, there was this little company where people came into the doors and they came out millionaires. It was called Apple Computer. You may have heard of it. And I went to a guitar concert, and right after the guitar concert, I went to a pizza parlor called Frankie's, Luigi's, and Johnny's. And the guy I went with was, the guy I met there was a guy named Dan Kotke, who was an Apple employee number 10. And somebody showed up, kind of an arrogant little prick named Steve Jobs. And Dan nudged me in the ribs and said, you see that guy over there? He just became worth $300 million today. Well, this exerted a strong magnetic pull on me because my goal was to make enough money to retire early. And it looked like I would be doing that if I could get into Silicon Valley somehow, say a Silicon Valley startup. It looked as easy as pie. Just find my Apple computer. And I had a short interaction with Steve Jobs then, and then many years later. And I went to work for Steve Jobs eventually at Next. Yeah, that's another story altogether. But anyway, I went to work for an employee of Steve Jobs named Jeff Raskin. And Jeff quit Apple when Steve elbowed him aside from the Macintosh project, which he created at Apple. And he worked on the first motherboard for the Macintosh, and actually he completed that much of it. But then Jobs decided that was the future of Apple, so he wanted control of that project, and that forced Jeff to quit and found his own startup company. And so I went to work for Jeff. 6 startup companies later, I still wasn't a millionaire, not anywhere near it. And the final insult, to add salt into my wounds, was when we designed a smartphone before there were any smartphones. And it was based on Jeff's idea. Jeff was very much like Fred. Jeff Raskin was very much like Fred. He had iconoclastic ideas that weren't accepted by the mainstream, but then when they tried them out, they worked beautifully. For example, the GUI interface, GUI, graphic user interface, which we're using right now to do the Zoom call. It became the standard, but it was just a twinkle in the eye of Xerox PARC. And I remember going to Xerox PARC when I was in my 20s. I used to hang out at Stanford a lot. And I wound up going over to Xerox PARC, and I saw the first graphic user interface with a mouse and a bitmap screen and everything. I thought, what would people do with this? I don't see any use for it. But Jeff looked at it and he saw a use for it. So he convinced Apple to put out the Macintosh, which was the first computer with the graphic user interface. And then Microsoft stole the idea, and now it's the world standard. And there were lawsuits over this. I mean, God, I could talk about this for 25 hours nonstop. I wound up spending 20 years in Silicon Valley, and then the final project was Jeff had an idea for a smartphone, and the company we were working for at the time, I don't know if I can say their name, so I won't say their name, but they're very, very big. They said, well, great idea, you guys, but we won't give you a GID, a graphic interface device, meaning the touch screen, which is now standard on the iPhone. And we said, you have to have a touch screen or this won't work. And they said, no, it costs too much money. So we basically wrapped up the project. And at that point, that wasn't what made me quit. What made me quit was the iPhone came out 3 months after we closed our doors. And the world went nuts for it, which is what we predicted. But it wasn't exactly what this company wanted, which was a push button phone. We know what our users want. They want a push button phone. Make it like that. And we said, no, you want something completely original that's better. But they wouldn't believe it. Now,
I want a rotary dial cell phone.
Oh, you do?
No, I'm just kidding.
Oh,
No, I'm just sorry to interrupt you.
No problem.
No, you're
probably
you're
need
right.
interrupting.
You're right on with that, with Steve Jobs and the technological revolution. It's crazy.
Well,
you were right next door to all that was going on.
Oh man, yes, I was right next door to it, and I watched it happen. It was not exactly a surprise how big it got, but it transformed the Bay Area where I grew up into a place I don't even want to visit anymore. It's just lost its charm, its humanity. Now it's money. I can't stand it.
I think the same thing is going to happen with anti-gravity. That's why I'm so not worried about patents at this point, because I realize that this industry is so freaking massive, and it's so overpowering. There's so much money is going to be poured into this that there really is there's nothing to fight over. Like what do you want? 1% of the industry? You're a trillionaire at that point. You're a billionaire at least. This is a multi-trillion-dollar industry, and it's going to eclipse the economy of the United States within a couple of years. It's going to be an international affair when anti-gravity is truly discovered and truly disclosed.
I absolutely agree with you. And mark my words, they're going to call it the extension of the electronic revolution into space, because in a way it's related to this digital technology. That's how we're going to get vehicles that, like you're doing with the experiment, you're doing it much more efficiently than my dad was able to do it. He didn't have digital equipment. It was all analog in 1994. But when you get a digital manager for your propulsion system, it's going to be lightweight, it's going to be cheap, and it's going to enable everybody to go into space at will. Okay. By the way, we can deflect those asteroids that we're worried about. Here comes the asteroid. We'll get out there and blow it up long before it ever reaches Earth. It will not be a problem. Even if it's, on a course to hit the Earth in 15 minutes, we could do it.
So what happened after the whole ordeal with the iPhone coming out, and you lost out on that?
Oh, well, we lost out on that. And the thing was, the iPhone was inferior to the design that we gave to the company that contracted us. And then they copied the iPhone, clue, and they were sued by Apple, and they spent $1 billion on the lawsuit settlement. And they could have had a better product for just the price of building it. A few million bucks that they would have recouped instantly when people discovered how much fun it was. And the difference interface, by the way, was called a zooming interface. So instead of having
that's what we're on the zooming interface right now.
The zoom interface, but it was like a two-dimensional map, and using your interacting with the screen with your finger, you could fly into the map and into buildings on the map, and then find stuff inside the buildings, and then zoom out again to the broad view. So there were no menus, there were no windows, other than if you launched an application, so to speak. But that wasn't. It wouldn't be the same as launching an application on a Windows interface because, well, it would be simpler, a lot simpler. And this idea of flying through the two-dimensional map, everybody who's used the zooming interface says it's better than a GUI interface. And it's been implemented for hospitals, and they could teach a nurse how to use it and consult patient records and move stuff around. They could learn how to do that in 20 minutes compared to the learning curve with Windows software requiring, special instructor and just weeks of instruction. That just takes so long to do the learning curve on a Windows product. This is so much simpler. So they could have had a billion dollar product, but they decided to go with the crummy version. That's what made me quit. Even when I have a great idea, I always wind up on the losing side of these propositions, these startups. So I decided, if I don't get out of here fast, I'm never going to write what I want to write. So
I think you really made the right decision, because with this technology, there is no losing side, really, because it's going to be such an explosion of technology that there's going to be a lot of companies investing in it, major corporations. They're all going to want a piece of the puzzle. It's going to be an international affair, and it'll be literally a run to the patent office to patent all these technologies and do it as quickly as possible. So anyone with any knowledge in this field already will be scooped up, and I think there's just tons of money to be made, and overall, most importantly, good for humanity. Like just mining the asteroid belt, getting rid of these open pit mines that we have here on Earth, getting rid of the whole gold delusion. What do we need gold for? Gold is useless. I mean, it's good for
precious metals will no longer be precious anymore, because
except for silver.
Abundant.
Silver is important. Silver is important. We need silver for a lot of electronics, but gold doesn't do anything. It's useless.
When I was growing up, I heard a lot of kids say, well, why do we want to go out in space? There's nothing out there. It's the opposite is true. Everything is out there. A new frontier, all the resources you could possibly want, plus who knows what kind of archaeological finds we may make on Mars or the moon. It's a whole new world. It will make our world look to the future like we now look upon the Middle Ages in short order.
Yes, exactly. They're saying that one asteroid is worth more than the GDP of the entire planet.
Yep.
One asteroid is, well, obviously, if you brought that asteroid in, it would just bring, the price of steel down to zero. But still, like, you could chop off a little piece of it and you'd be a trillionaire. You'd be Saudi Arabia of steel. And it's also, these materials that are in outer space are highly purified too, because in the core of a planet, basically the asteroid belt was a planet that blew up. And there's theories as to how that happened. It was probably some war or something like that,
right.
Star Wars style, or maybe there was a massive collision. There's a lot of theories as to what exactly caused the asteroid belt. But bottom line, you're looking at pieces of a core of a planet. And in the core of planet Earth, all the heavy metals are all molten. They go down by their atomic weight or by their physical weight. So when you smash a planet apart and then it solidifies, you'll end up with asteroids that are of a solid element, of a single element. unless they're in like a transition period section, then you'll have two, or unless there's like two elements that weigh similar amounts. But you're going to end up with literally asteroids of an entire element. Then you don't have to go and purify all this shit and, you know, destroy our planet doing it. Like, the biggest problem here on planet Earth is what we're doing to the rivers, what we're doing to the water, the contamination of the planet. It's not just the CO2. It's all the other ancillary things that happen because of that. And by fixing this one problem, just mining the asteroid belt, we will fundamentally change life on this planet for the better. And, you know, not to mention how the extraterrestrials will probably make contact, just like Zafram Cochrane did. You know, brought on the what are they, the Vulcans? The Vulcans, you know, arrived because they saw a warp signature. I would assume a similar thing would happen here on Earth once we achieve actual anti-gravity.
I totally agree with you. Because as long as we use rocket technology, we're really not a space race. And I mean that in the other sense of the term, not the race to get there. I mean a species that has graduated from the seed husk that gave them birth and now has joined the interplanetary and interstellar civilizations that are already out there. And the reason I think we're not hearing them, by the way, is because they're broadcasting on another channel altogether. And that's another technology that has yet to be awakened and may awaken as
I think I know what that technology is. It's called spooky action at a distance, or quantum entanglement. It's possible to create two entangled pairs of electrons or protons or neutrons or atoms. So once you get up to a quantumly paired atom of hydrogen, what do? You stick it inside of a device, and then one hydrogen atom talks to the other hydrogen atom through time and space. And this is very important, because now you have a direct contact down to base, instantaneous, no matter where you are in the universe or when you are in the universe.
It's fantastic.
And when. You could go through time travel and still be able to communicate live with your base, so long as they have their machine that's connected to that you know, quantumly entangled hydrogen atom, and you have your machine. You can contact, you know, throughout time and space.
It's very Star Trek-ish. And,
yeah, they also incorporated in the new Star Wars movie with that whole communicator that they had, which worked on the quantumly entangled pairs and stuff. It was in the new one that where Chewbacca died, not Chewbacca, Han Solo died or whatever.
Oh yeah.
By the way, the abundance of iron is the most abundant. One of the most abundant. I think it's the most abundant in the universe, and it's because of it has the highest binding energy out of all the elements.
Actually, it's because it's the element that's created right when it's the lowest element that is. Yeah,
it's the last one that stars create. So it's
the last one that stars create before they go supernova.
Right, which is why there's so much of it, and then it just creates all the heavier elements in the process of supernova afterwards. So
aluminum is a very abundant element in the Earth's crust. I don't know about elsewhere, but makes it easy to build flying saucers.
Yeah, aluminum's great.
It was the first metamaterial. The first true metamaterial was aluminum.
But just don't use aluminum to house your, if you guys want to try to build like the spinning mercury experiment, a bunch of people were talking about in the chat. Mercury creates an amalgam with aluminum. If you put mercury on aluminum, there's some really cool videos of mercury. You put mercury droplets on aluminum and some really weird crystals and amalgams form. So yeah, don't use aluminum if you're going to build a vessel to house mercury, because they react.
Here's my pound of mercury. I actually have a couple pounds of it, and wow. I'm not sure exactly what I'm going to plan on trying with it, because once I read the OSHA description on mercury, I was a little freaked out. This stuff can damage your brain for life, and if there's a way to do it with heavy water or something like that, I prefer to try, you know, that spin version first, because as I understand it, you're just using the mercury because it's a heavier liquid, not because there's something really special about the mercury. You can use water as well. It just doesn't work as efficiently.
I think you'll be able to do it with aluminum, simply because the decay time for nuclear orientation.
We're talking about something completely different.
Okay.
Spinning the mercury around, we're talking about a different experiment. where you
Oh,
spin the mercury around in a chamber, and instead of, you know, it's sort of like the center of the ARV. So it's the spin version instead of the microwave version. The microwave version is kind of like it's the solid state. It's the advanced tech that, you know, the advanced aliens use. When you're trying to build the horse and buggy, you spin it around. This is the horse and buggy version of.
Well, he had also mentioned that rotating the sample did different things too, and also maybe processing it like that precession, that weird coin on the edge effect, which was an effect of this precession. Maybe if you were to force the craft at that precession, it could get the gyroscopic effect of these things rotating in that same kind of precession.
I want to show you guys something kind of cool. So this guy contacted me from Britain, and he claimed that if I were to mix, I had him on video chat, and he claimed that if I mix mercury with barium titanate, which is like a material that's used to make capacitors, it'll create some anti-gravity effect. So I was like, fuck it. I actually have those two things. I mix them together. So this is what it looks like when you mix mercury and barium titanate. It basically.
I can't
I
get
wouldn't
you
want
on
to drink it. I could tell you that already.
Oh no, you don't want to drink it. This is pretty fucking toxic. But this stuff.
I can't get you
what
on
happens when you mix
screen.
mercury and barium titanate. They don't actually mix very well, but the mercury is a bit dirty. So
Yeah.
it hasn't flown off my desk. It's been here for at least a year, sitting inside this pill bottle. Hasn't gone anywhere yet. So there's to that theory.
Well, when you have a good theory, then you can aim for a result in an experiment and know right away whether the theory is false or true.
Are you guys ready for a tour of the lab? We can show everyone what we got going on so far.
Mark,
Okay.
I can't. I'm not ready for a tour of the lab. For some reason, Zoom is not. I'm clicking on your icon and it's not letting me blow you up. David is locked on.
Okay, how about now?
Well,
no, it won't let me. It won't let me click over to you on my main screen. I don't know why. It did this before, and then it stopped, and I was able to click on all of us and blow us all up. But now it's not doing it again. I don't know why.
may I just say something about the
again? I just made you host.
All right. I don't know why it's not letting me choose. Oh, there we go. Now I can choose. All right. Now I made you. All right. Now I can see you. You want to give us a tour of the lab? Show us the current Alzofon setup. We had it right to the left of you over there in the open area, but I guess you moved it.
I was actually the entire time I was inside of the lab control room. And the laptop that I'm talking on is actually the laptop that we use to measure the weight on the experiment. So what we have over here is, first of all, this is the power supply for the electromagnet. And it was modified in order to have more control over the current regulation. And to read the current more accurately, we built this custom shunt. I bought one on Amazon that's going to be a little bit more accurate. We're using a voltmeter that then shows us how much current is going through the shunt. Right now, the power supply indicates 3.9 volts at 4.4, or 3.9 amps at 4.4 volts. So that means we're only using about 17 watts in order to power up the electromagnet. That's all it takes to reach the requisite Gauss reading. This is the traveling wave tube amplifier. It was a tricky thing to find at first. We tried renting one at first and had trouble with that. Then we tried buying one. It was broken. I brought another one, and before the guy shipped it, I told him, listen, I've had problems with these. They're always broken. He was like, no problem. If there's a problem, I'll give you a refund. So he sent it out to me, and sure enough, it was broken. But it was broken in a way that you power it on, it didn't even power on properly. And to an engineer, that means usually easy fix. It's usually easier to fix it when it doesn't power on than when it powers on and something's wrong. So he gave me a refund because I asked him, told him that thing's not working. And I took it apart after I got the refund because he said you can keep it. And I went through the instruction manual on it, which was very well written. Whoever put that together, kudos to him. Explains exactly what parts to check with your amp meter and whatever. I was able to repair it. So I ended up with a traveling wave tube amplifier basically for free. And this is our signal generator that sends out the signal. It's only able to do 9 to 9.5 gigahertz, but it has a lot of pulsing capabilities. You can see this is the constant wave version of it. There's pulse, there's ×1 divided by 10, and there's all these different knobs that control it. Internally, it's all pretty much mechanical. And the numbers that I've been seeing here on the gigahertz output are way off from what it shows on my signal analyzer. The signal analyzer is inside of the Faraday cage, and it shows us what pulses, what energy is actually coming through. This is our oscilloscope. It's connected to the signal generator, and that's to show us the pulse length that we're set at. So right now, I think we're set at measure, I want display. No. Measure display all, there we go. Okay, so yeah, we're at pulse width and negative width of about 6 milliseconds, which is what was prescribed in the experiment. Traveling wave 2 amplifier is not turned on right now, so we're not going to be able to see anything. And every time we turn it on, we flick this little switch over here. This is a switch that alerts everyone on the other side of this wall as to what's going on. So on the other side of this wall is a Faraday cage. You can see the lines that are going in through the wall over here. There's 2 holes, and there's a hole there on the bottom. And they're strategically placed for different aspects of the experiment. This line over here is for the high voltage, for the RF. This over here is for the spy cam that's inside the Faraday cage. This one over here, what is this one? Oh, this is the USB cable that goes to the laptop. Down here is the, no, this is something else. No, this is the USB and the spy cam. The USB and the spy cam are together. The power supply for the electromagnet is down there. And I also have, this is the signal analyzer, like the returns for the signal analyzer to see what RF we're pumping into the Faraday cage is on the other side. So now I have the alarm turned on. I'm just going to come around to the other side of the shop and show you. This is the Faraday cage over here. It is the size of a room. So we're literally going to be able to go inside and show you what's going on. There's a door over here. That's our warning light, so that when the experiment is charged, nobody goes inside accidentally and gets hit with the radiation. I have done this in the past, just trying to shield my face and doing it in open ear, but it would always give me a headache. And this is only at 20 watts. So when we try this experiment again at like 3,500 watts with that power supply that you just picked up, Jeremy, I'm not going to want to get anywhere fucking close to it. No.
You know how many decibels that is?
I don't know, but decibels is a funny scale. Like every time you go
it's
up,
logarithmic.
Let's just talk about the wattage. We're talking about 3,500 fucking watts. That can cook your brains out.
Yeah.
I'm going to show you what 3,500 watts is coming through. You'll see. You'll get badly hurt if you got hit by 3,500 watts in that area. Now, this Faraday cage is a double layer Faraday cage. It's actually like has capacitive layering. There's 2 separate grounding rods that go into it. There's the inner chamber and the outer chamber, and they are separated by sheets of plywood and 2x4. The outer chamber is connected to a 4-foot ground rod, which is down over there. And in the center of the inside, we have an 8-foot grounding rod, which goes down to the bottom. Now, hopefully, I'm not going to lose signal in here. I'll keep the door open. But right over here, we have the EPR NMR laminar spintronic alignment rig. It's also known as a electromagnet. And that is where the sample is being held. The sample is on a string. I can't really see what you guys are seeing, so I hope this is right. It's being held on a string, and there's also guiding wires that hold it in place. You can see that little light down there, this little guy. This is the spy cam that was on the other side. The green antenna, that's a Yagi antenna that we're using to pick up the signal for a signal analyzer. The blue thing over there is a capacitor that we're using to clean up the load. This bucket is full of salt water, and that's used to capture the extra electromagnetic energy that was wasted from this process, because we don't have any way of containing the RF, so it bounces all over the place in here. We want to minimize that disturbance with using salt water as a load. So as soon as the RF hits the salt water, it stops. I have plans of putting a fish tank literally along the entire length of the Faraday cage on that side, and it should make it like 3-4 inches deep, out of plexiglass, and fill it with salt water. No fish, of course. And when we could put fish in there. I don't think it would hurt them, because it would just heat up the water slightly. And this is the RF input over here. You can see this is actually where the antenna is. The antenna's in that little space over there. It goes vertically this way. This is a isolator. It basically stops any return RF from coming back and hitting the amplifier and hurting it. It works off of principles of a permanent magnets that are inside it that are probably in the shape of the waves. It's like a one-way valve for RF. This is called an attenuator, but we're basically just using it as a waveguide. It's made out of aluminum hull with stainless steel bolts, and we're just using this as a waveguide to keep the magnet in the isolator away from our super electromagnet over here. And finally, at the end is a waveguide. This is actually something that I 3D printed. Let me see if you can see that. We 3D printed that on the printer here at the shop, and covered it with aluminum foil to, attenuate the signal to direct the signal in the exact direction I wanted to try. We also have some purchased ones. This is one I got off eBay for $30, and this one was donated by a guy named Carl, who we met at AlienCon. Jeremy, you remember Carl?
Yes,
Miller?
I do. We stood in the lunchroom line and had lunch with Carl. Yeah, of course I do.
For the RF.
Give me 1 second. Mute your mic, and I'll get you on.
There's a couple of issues. First of all, we got a lot of RF interference with the scale. The scale would go off the chart sometimes at specific frequencies. It would go to like -200, like numbers that made absolutely no sense. And we had to ground the hell out of it to get rid of all that noise. And that's why the scale looks like it literally has a tin hat on it. No, a tin coat. They're making fun of us for having tin hats. Look how much aluminum it took to shield my little scale. We actually have a bilayer over here between the RF interference point, which is down by the electromagnet, and the scale, which is up here, which probably uses some piezoelectric effect. And finally, after putting in several different grounding wires, he finally got rid of the noise issue. Another issue that we're trying to work out on is the exact Larmor precession frequency, because that is related to the strength of the magnetic field. One number we found on one website was 28.025 gigahertz per Tesla. Then we found another number on another website, which was 27.209 gigahertz per Tesla. And then we met this other a PhD who works for a company that makes NMR tabletop machines, and he actually said it was way lower than that, or way higher. I don't remember, but we're getting all different kinds of information as to what the exact frequency and what the exact Gauss reading we would need in order to run this experiment correctly. So that was something I was really hoping David would be able to enlighten me on, because unless I get that close, there's no way we're going to find it.
I can easily find it. So let me do that after the interview here.
But don't trust anything you see online, because I found a lot of sources pointing in all different directions, and it's possible that it depends on the sample itself. Like that aluminum has one specific frequency, and bismuth has another, or something like that, and hydrogen has another. So you got to really dive in deep and make sure you're giving me the right Gauss reading for the 9.5 gigahertz that we're running the test at. And
let me see what I can. Sorry,
I can play around with it a little bit, but there's only so much control I have on the dial to really fine tune it.
Let me see what I can find.
That's something you can pull that up later. It's not necessary right now. But if we can get like an absolute number as to know exactly where to orient it, or if you don't know, then we'll just have to go with different sources and, you know, try everyone's theory. Because for me right now, all it is just to switch a couple knobs, and I have the experiments pretty much set up. We're ready for low power, and Jeremy has this massive power supply he's going to bring down here to the lab when the Klystron arrives, and we're going to do high power. We're gonna fucking cook this place. So like if the aluminum doesn't lose weight, we'll vaporize it so it weighs nothing.
Oh yeah.
Okay.
I promise you that. Okay.
So I take it that will take a while then to arrange. And,
no, I think it's supposed to be here sometime next week. And Jeremy picked up a power supply that is powerful enough for it. You actually need like a lower voltage, not like the crazy high stuff for T. Townsend Brown. You need like 5,000 to 10,000 volts, but high current. So he was actually at a lab sale, and there was this power supply there, 5,000 volts, half an amp. That's 2,500 watts. That's like 2 microwaves right there. And I was looking at that. I'm like, dude, you got to buy it. Jeremy, how much was it?
All right, so this is an estate sale. So this is how I found it, people. Just so people know. I go to a lot of like MIT flea markets. Brown has one too. You go to like the big schools that get a lot of money because they have lots of money. It comes from big money. You know, it costs like, what does it cost now to go to Harvard per year? Like $80,000 a year. So they have enough money at these schools where they just, when stuff gets old, it gets fully depreciated after like 2 to 3 years, rather than other universities where it takes like, you know, it can take 15 to 20 years to fully depreciate. So they replace a lot of their equipment a lot faster, and it goes to these MIT flea markets and then gets picked up. So I went to this is how I found this particular sale though. I went on Facebook, Facebook yard sale, and also on Craigslist, and you search for lab. I just do a search for lab and laboratory every day. You know, this is one of my daily routines. I have a list of things I go and do searches for. You know, and that's one of the things. You go to like Facebook yard sale and search for lab or laboratory, and you find these estate sales.
Do that right now.
Right? No, I'm letting you know my secrets, and like I'm gonna get other people digging into my stuff. But this is important because we only got 100 people watching on the live stream right now. We're back down to 106. We had like 130 at one of the high points, which was really awesome. It's kind of unbelievable because people are pointing out I have more subscribers than Richard Dolan and some of these other big channels, yet they get 700 people watching some of their live streams, yet we only have 110 people watching this. You know,
I kept on bringing that up in the chat, and I'm posting the link to this live stream everywhere.
Yeah.
You guys, everyone who's watching this right now, go and copy paste this, because disclosure is happening right here on Alien Scientist. This is the real disclosure. Anti-gravity is real disclosure. We're not talking about aliens. We're talking about how to get to the aliens. And that's what's most important.
And we're talking about the real people that were involved with some of these programs that were funded by the big aerospace companies and directly related to some of the biggest physicists and some of the biggest scientific minds of our time. And this is where all the real secrets are, is in these classified programs and hidden away in this stuff. And this is what my goal as an alien scientist is, to dig into this kind of stuff and expose it.
And may I just say very briefly?
Absolutely.
Yeah. I just want to remind everybody listening that everything we're talking about in terms of my dad's technology has been on the public record since 1981, including several articles that he wrote for the MUFON Journal that are very detailed technically. And of course, all of his scientific papers. There's nothing classified. It's all been there all this time, and it's absolutely driving me bonkers that nothing has been done about it because of institutional inertia. And it's really time for that to end. So bravo. You guys
I have no institutional inertia because I never went to the institution.
So having said that, David, can you? Someone asked about you commenting on the secret space program, and I just want to I don't want to go there with the secret space program stuff. Like, why don't we just talk about secrecy and in general, like how easy it is to hide, secrecy, especially of an intellectual level and on an intellectual level.
Well, my dad was never. He never faced outright oppression, suppression, or threats. Never. That never happened. But he didn't get any support either, and his work was made obscure because his reputation in the field was never established, and it was never established because no university would allow the research to go on behind, at least in the open there. You guys have run across some evidence, and I've run across some evidence that it did go on, but behind a solid lead door 6 feet thick, so nobody knows about it. It should have been shared. It should have been shared because the benefits to humanity would be off the scale if it's correct. I believe it's correct. I don't disguise that fact, but speaking as a scientist would speak, you have to be careful to couch your words in a certain amount of modesty and skepticism. Anyway, I think this is the right way to go with research. But when you're talking about secrecy, it's just pathetic what's happened since 1947. The instincts of the people at the Roswell Air Force Base was to just tell everybody everything, and that was the instinct of a number of people on the inside too. But there was another group that wanted to keep it all closely guarded. And where are we now? Well, we're victims of inferior technology in terms of environmental destruction. And we could have been free of all of that a long time ago. Minimally in 1981, but maybe as far back as 1950. If we'd had the world's best scientists looking at the technology that was captured at Roswell instead of people throwing garbage can lids and saying, ha ha, flying saucer, and making people afraid to even talk about the subject. So that's the price of secrecy. I think it builds a deep neurosis into society and does damage, physical and mental, spiritual, to the society. We are seeing the effects of that damage.
It's really sad. It's really sad that we've gotten to this point and that it is like the way it is. But I think you're right. The skepticism needs to end, and I think once we crack the technology and are able to demonstrate this and show this, and if indeed nuclear magnetic resonance plays a role in the actuation of gravity, I think that is something interesting and worth finding. So, Mark, let's talk about these experiments and where you and so Jeremiah had come down to the lab, and he was working with you on setting up some of these experiments, and you guys had gotten to a point, and then Jeremiah had to go back, and you're still working on this.
He really comes down here to work on the Falcon hybrid stuff, and we work on Falcon space on the side. My main job is actually hybrid battery refurbishment, and that's what you see behind me, is these hybrid battery modules. So if anyone out there has a hybrid vehicle, needs a hybrid battery replaced, come to us, and the proceeds may go toward anti-gravity craft or anti-gravity experiments, because I'm trying to just push in the direction of a cleaner planet. So we start with the hybrids, and we're pushing for the anti-gravity stuff, which will be energized probably by hydrogen fuel cells.
I don't want to be rudely interjecting anything here, but have we been ignoring the audience? Are there any questions out there that I could answer before we go on?
I asked
Be
everybody.
careful.
I've been asked several times. Everyone has questions to ask them in caps, and I've been monitoring the chat and trying to keep track of all the best questions and that
Okay.
we need to ask. And I brought all the ones I believe up that were relevant and stuff. We will get to those if anyone continue to ask questions. If you're in the chat, just type in all caps, and we'll try to get to your question and ask it live with our guest. We're nearing 2.5 hours now, of sitting here into the stream, and I probably have about a half hour left in me before I'm about to, we're probably going to end this around midnight tonight. So get your questions in now if you have them, and we're trying to wrap this up. Of course, the experiments are ongoing. As we said, we've ordered a new thyratron to try this at a higher energy and a higher power at 6.2. A klystron and at 6.2 gigahertz to work with the new wave. I got a bunch of these waveguides at that lab. So back to what I was saying about the lab sellouts and stuff. So you search for laboratories and you find these estate sales. And what this was a scientist who ran a laboratory that was up here locally in North Dighton. And the guy had purchased the property with his brother, and they're trying to turn it, repurpose the property into
Jeremy, you got to change the screen so that you can see you.
Yeah, no, it is. It's on me now. So, anyways, they had an estate sale of all this old scientific equipment, and I had gone there and talked to the guy, and I told him about what we were doing and about some of the research that we were engaged in and stuff, and that I think that made him willing to sell these things to me at a lower price, because really that power supply that I picked up, the 5,000 volt, 500 amp power supply, was he gave it to me for $50, and it's probably worth more than that. It's easily worth more than that in just scrap alone. The thing weighs a ton. It weighs not a ton. It weighs probably about close to 200 pounds. Close to 200 pounds, I'd say. It's really fucking heavy. And sorry, excuse my French. There I go. My first swear of the night. I came this far, and I had to drop the F-bomb. God.
Put a quarter in the jar.
Yeah, put a quarter in the jar. There it goes. Anyways, yeah, it is extremely heavy. But the guy did sell it to me for $50, and he also sold me a lot of the props you see in the background, which I'm still in the process of hooking up for. To make the live chats and the live streams more interesting to our guests, to have more stuff go on in the background, which I can control on my little control board here. I have an app on my phone to control some of these things in the background, so I can make the water start boiling and other things happen.
Oh, so they're asking in the chat, and this is something that I thought you brought up before. How is there weight loss when there was no magnetic field present and there was just RF?
Oh, you're talking about one of the experimental runs. Now my dad wrote notes about that particular experimental run, and I would call it up on the screen here, but I will have to reproduce it from memory. He thought that there was some residual magnetism in the coils of the big electromagnet. He said there could have been other explanations, but I'm not sure what they were. I don't think that they necessarily showed that there were numerous runs that worked, and then when you switched off one of the parameters that was under study, they didn't work. For example, when you stepped outside of the pulse rate, you got chaos. When you ran the experiment without, okay, let's see, the one that was without magnetism and it worked. Yeah.
There's actually somebody in the chat who offered an answer. He's Greg Chase said he used iron in the samples. Off-magnetic tests with weight loss is due to magnetic remnants sample has been subjected to test runs. You need to heat above the Curie point to remove the remnants. Are you familiar with that explanation?
No, I'm not.
Basically, he's saying that the iron in the sample retained some of the magnetic field that was applied to it earlier, and the RF was able to still interact with it because the magnetic field was there earlier and sort of oriented the more processions.
Well, I'm glad there are readers out there who are familiar enough with the experimental report to bring that particular trial run up. I looked at it and I thought, people are going to look at this and think that it was dispositive as far as the theory goes, but that's not what my dad thought. It was he thought it was the type of thing that meant you needed to repeat the experiment with better controls and strict isolation of the variables and remove the variables one at a time or in multiples until you'd done a complete cross-table study of everything that went into the experiment. Now, what I think when I hear this is that there was something unaccounted for with their instrumentation. There was a magnetic field, but even though they had switched off the equipment, I think that that was the problem. And what your audience member brings up is the possibility that the iron, microscopic particles of iron in the sample had retained magnetism, and this was causing something to happen that wasn't predicted in the experimental results. But then you look at all the other experimental results and they're very encouraging at the very least. So I don't think this that particular run was a disaster. It just tells you that you need to do a better version of the experiment next time. That's all.
Further research is necessary because there shouldn't have been weight loss in the first place. The fact that you have it on, a control, or what, they would consider a control, doesn't necessarily mean that there's nothing happening. It means that we don't understand it fully.
Well, also notice that when you were during the successful runs, if you look at the charts, there's that zigzag pattern going down, which was predicted by the theory. And then when you switch off the microwave pulses, the weight returns to normal in a smooth line. So this was also predicted. There were so many things that were predicted that did happen that this definitely means that this is worthy of further investigation. And that's why I included that particular chart in there. I didn't want to hide anything and then have people come along later and say, well, you hid that chart from us because you didn't want us to see the whole picture. Also, that I think there was an Amazon review where somebody was irate about that chart and said that there was an attempted concealment from the investor. No, the investor was present when that particular run occurred, and so nothing was concealed ever. That was totally out of character for my dad to conceal anything. That's another reason I put it into the book. No, it just means a better set of experimental devices needs to be built and better runs. For example, nuclear orientation, there needs to be some way to measure that and make sure that it's taking place in the sample. And I'm not sure that that was done during the first run, and Marcus said it's going to be difficult to measure it.
I'm not sure if it's possible to measure it, so don't count me on that. It might be very easy to measure, or it might be impossible. I don't know.
But it's no kind of a test at all unless dynamic nuclear orientation is taking place.
We'll have an expert on dynamic nuclear orientation. And I actually know somebody who knows one who worked at an EPR machine back in the 80s, I think, and has since retired. His father-in-law was an EPR expert. So we're in contact with somebody who knows this stuff really well. And from what we've heard so far, the magnetic field needs to be extremely laminar, and you need to have a lot of control over the RF, more than what we have right now.
I see.
So
you need to be able to control that pulse width, and the square wave has to have very sharp sides on it like that, or you won't get the effect.
Yes, that is true.
Does everybody understand that the reason this is expected to work is because it is analogous to cryogenic freezing, adiabatic demagnetization of paramagnetic salts is a proven method for bringing the temperature of test samples down to within a hair of absolute zero. This is a way of doing the same thing that cryogenic freezing does on a molecular level, but we're doing it on a subatomic level. The processes are analogous, almost perfectly analogous. So we expect that if you are able to establish nuclear orientation, the Earth's gravitational field will interact to make it, to randomize or make the processes that are responsible for the interaction between Earth's gravitational field and the object with the side effect of weight and mass. Those effects will be lessened because of the work that the gravitational field has to do on the oriented nuclei of the sample. And that's what reduces weight, the reduction in the interaction between the object and the gravitational field of the Earth. And now we're on the brink of going into the unified field theory. But, you know, if I may, I'd really like to say a word about that.
Go ahead.
Yeah. There's a beautiful phrase in the, I'm going to have to paraphrase it because I don't have the text in front of me right now, but in my father's discussion of gravity in Gravity Control of Present Technology, and that is that it is characteristic of gravity that is present wherever there's mass, and that there has never been an effective method developed for shielding objects from the effect of gravity. You see it wherever you see mass and concentration, doesn't matter what the temperature of the mass is or what the composition of the mass is, the amount of gravitational pull is directly proportional to the amount of mass, and nothing can be shielded from it. Now, this suggests that the physical process that gives rise to the gravitational field has something to do with a common element for mass, wherever you find mass, regardless of temperature, regardless of quantity, regardless of composition. And the thing that all mass has in common is subatomic particles. It's all composed of the same elementary particles. So you would look for a common property in elementary particles that might be responsible for the gravitational field. Now, while my dad was at the cyclotron, he was observing elementary particles. And one of the features that was discussed was and it was ignored in terms of the experiments, was the existence of a virtual process field surrounding the particles. So, for example, if you have one elementary particle, it's going to have a boundary that's actually not as clearly defined as a billiard ball. It's going to think of it as an energy field that has a variation in density, where this density at the center of the particle is high, but then it shades off into a bell-shaped curve the farther you get from the center of the particle. At the fringes of that bell-shaped curve is something called the virtual processes. The virtual processes are, well, to put it in one phrase, the creation and annihilation of charged particles on a subatomic plane. It is known to exist, but it can't be observed because it's not within the range of an optical wave, and it's also extremely transient. Now, in my dad's theory, this virtual process cloud surrounds particles. It also surrounds planets, galaxies, everywhere there's matter, and it is the same as the gravitational field. So here's why. Here's why it produces an attractive force. If you get two objects in let's say two elementary particles in proximity to each other, their virtual process clouds are going to overlap, and there'll be a common area between them where the density is higher. This means that let's say that you characterize, I hope I'm not getting too technical for y'all, but if you're going to characterize the diameter of an elementary particle by Planck's constant over a mass times the speed of light, that's the Compton wavelength, that's called. The Compton wavelength is also a measure of the extent of an elementary particle, so that you have to change that particular value when you have an area of shared virtual processes, because the M will become M plus delta M, where delta M represents the area of shared mass, because from the viewpoint of this particle over here, it says, aha, I've got extra mass now, contributed by this particle over here. And from the viewpoint of this particle over here, it says, oh, I've got extra mass now. And so each of them has M plus delta M in the Compton wavelength of that particle. And if you think about it, this means that the diameter of the mutually shared particle fields has to shrink. So there's a general flow of energy towards the center, and this accounts for the gravitational effect. It's very slight when it's between particles. It's negligible, but it's very large when it comes to planets and galaxies, and it's the force that drives the universe. And it is a side effect of these virtual process clouds that surround elementary particles, and by virtue of that surround planets and celestial objects.
And these virtual process clouds, that's what a lot of these other physicists, I believe, refer to as the zero-point field, the ZPF.
It's an alternative explanation for the zero-point energy. This is something Feynman wanted to get rid of, the zero-point energy. He said intuitively it has to be wrong. And my dad's theory does eliminate it, but it doesn't mean that the concept is wrong. It just means there's another explanation for it, and that it isn't uniform in value, because it'll depend on the density of the virtual process clouds. But it does explain black body radiation, for example, and other.
We were talking before about matter and black matter. Well, for Black Lives Matter, Jeremy, can you show the screen a second?
I think Black Lives Matter.
Of course they do. You matter. Everyone matters. Okay. Unless you're going at the speed of light. Then
if you're going, as you say, you give the punchline.
Yes, of course. The energy is, times the speed of light. Matter.
Right.
Light.
Oh, and by the way, within the framework of this is beautiful. I have to interject this. Within the framework of my dad's theory, the speed of light is not an absolute limit to acceleration. There is no speed of light barrier. This has to do with the only way we know about what's happening with something out there moving at close to the speed of light is by an exchange of electromagnetic signals. And the nature of electromagnetic signals gives us this artificial barrier. So this is, by the way, I'm soon to publish 3 lectures that my dad gave on relativity, which will explain this in greater detail. I found them among my tapes, and I digitized them, and now I have to what's the word? I have to transpose them to words on paper and publish them as a lecture series. But I haven't done that yet. Anyway, within the framework of the theory, it's an apparent barrier, but not an absolute barrier. And if you have a way to counteract inertia through this process that we're beginning to experiment with here, we should be able to neutralize it for an object moving in space. And the objection, of course, has always been the closer you come to the speed of light, the greater the mass becomes of your vehicle, and finally it becomes infinite, and you can't break through that barrier. Nature doesn't like infinities. There's usually some kind of a threshold phenomenon that occurs when you translate from one form of matter to another, and there should be something happening at the speed of light. But the speed of light is not a barrier. You can go many times the speed of light if you can cancel inertia. And that is something I expect to see happen. If our experiments are successful, we will have faster than light vehicles as a side effect of this.
It's interesting that you pointed out about how nature doesn't like infinities. And yet infinities is the speed of light is like cited as this infinity, you know, this speed limit, this ultimate speed limit in the universe. So we always get the speed of light is. It's just interesting that, you know, nature doesn't like infinities, and that, like, yet the main explanation that are given to us by these celebrity physicists like, you know, Tyson and Kaku and all the other physicists that kind of parrot that rhetoric is that the reason aliens can't exist or can't get here is because Einstein and the speed of light, and you know, you can't go faster than the speed of light, and that just the distances just make everything way too far to travel. And
yeah, if you're going sub-light speed, they're too far to travel, but not if you're going
right.
100 times faster. Yeah.
Well, the whole issue goes back to quantum mechanics. What is gravity? We still don't know what gravity is. Our best physicists can't describe what gravity is. You know, your dad was one of the physicists that tried to set up some experiments back in the 1980s to figure out what the hell is gravity, and it obviously had some merit to it, or else Boeing wouldn't have funded it, and they wouldn't have told him it was going to be classified more top secret than the Manhattan Project.
No, to be clear, it was Air Force.
And
who told him it would be, yeah. And also Boeing did not fund gravity research, at least to my knowledge. They didn't tell my dad about it. I think after he walked out of that Air Force meeting, his name probably went on the shit list of scientists to work on alien technology and to work on projects that he would have given his everything to be a part of. And so he didn't take part in those experiments. But I don't know. I'm sorry I interrupted.
Well, no, the people that they hire to take part in those experiments are scientists that they know that they can control through other means and other situations. That they know enough about their personal lives and their livelihoods to know that they can control them, and that they won't ever speak out because they're an economic situation. They're, you know, their family situation, and lots of other multi-layered things that go into what are called the dark arts of intelligence. Which is something I won't get into here, but it does exist, and we have to be aware of it as researchers moving forward through all this. It's interesting that your father's research, you know, it parallels a lot of ways to like people like Byfeld Brown, who was told, you know, like the way they kept it secret was by just ignoring him, while carrying on his research through other contractors privately, you know, contractors who could be controlled, people who didn't have, you know, your father's saintliness and his sort of, you know, like the drive that people like myself and the people that we work with have to really benefit humanity, you know, rather than the people that are you know, stuck in situations where they have to benefit themselves and those immediately around them. And
yes.
whatnot.
Yeah, that's the price that has cost us. It has cost us dearly to follow that policy, and that would be very beneficial if we gave it up. But the obvious fear is that somebody will get a weapon that is superior to anything we have, and we'll be at a strategic disadvantage, and correspondingly, we'll be at a strategic advantage if we have this technology. One of the reasons I wrote the book, by the way, was because I knew that paper had been out there for 36 years at the time I got started on it. And I also knew that one of my father's books wound up in every single technical library in China. So while the academics and the military people were busily, to my knowledge, busily ignoring the potential of his technology, it occurred to me the Chinese might not be burdened by that kind of a prejudice. And so they might have been doing work on it. And that made me scared for this country and for other countries in the world, because it would confer a strategic advantage. However, if it's out in the public domain, and everybody knows about it and everybody has it, it's going to go through an evolution somewhat like aerodynamic flight, where initially, well, some people were making a little better plane than somebody else, and then they caught up and surpassed, and a little better and caught up and surpassed, and we wouldn't have this outsized imbalance of that amounts to a strategic advantage. And of course, that was the big fear about Sputnik, and that's why they started talking to my dad in 1960. They were afraid of another Sputnik. I certainly didn't want to see another Sputnik as far as China getting a hold of this technology before.
Well, speaking of the Sputnik and China getting and other powers getting a hold of this technology, that brings us to this Air Force video that the Air Force can identify those objects that were filmed off of the coast, and that whatever that object was is flying around. And 36 years is a long time, for this sort of thing to remain not so secret, not so, there are much more better kept secrets than Alzofon. If I type in Alzofon into my search engine, I can find this stuff, and we came across it through our research into all the stuff that we were doing the digging on all the government research into anti-gravity, and this was one of the.
But when I told you about it, Jeremy, you've never heard of it before. You mentioned that you've never heard of it when I told you about Alzofon initially, and we actually found the Alzofon experiment through a comment on your video that we did mutually.
Right, and this is where we pride ourselves in. Like, I put out a thing and I said, hey, Hubbard Brothers, we came out with this theory page, and to compete with TTSA, because TTSA was sort of this a bunch of these government people like Elizondo and all these like ex-CIA people teamed up with this rock star front man, Tom DeLonge, to start this To the Stars Academy, and I wanted to compete with them to be like, well, these guys aren't talking about half the technologies and the stuff out there, the stuff that I come across in my research, and why isn't that? And so I wanted to come up with a list of all the different anti-gravity stuff. So we started like doing the digging and come up with like the master list and come up with the science and stuff. And this was one of the things we came across. And I said, Jesus, this is super interesting. And then, Mark here starts reaching out to the people, and we come up, he eventually gets in touch with you, we found your book. I think we bought a copy before we reached out and talked to you.
Right.
But, yet here we all are, and we're live in front of an audience of 125 people, and thousands of more will see this by the time it makes the rounds, which is cool, because we're digging into this stuff for real and finding out that these people did exist, and then these are their stories.
Yeah. Now, Mark, you had an experience that suggested that the military was working on my dad's technology.
Oh, yes. So when we were at Alien Con, I went into one of the main lecture halls, and there was a panel of like most of the speakers were on a panel. So it was like the master panel of all these speakers. And I came up to the Q&A section, wanted to ask a question. There was a lady in front of me who was talking about her fancy crystals warding off demons and, some crazy bullshit that there wasn't even a question mark at the end of it. And they decided to shut down the panel right when I got up to the mic. And it was like, obviously that they were shutting it down so that I can't talk to them. It was so obvious that the producers themselves, the speakers, came to the edge of the stage to talk to me. They're like, we're really interested. You look like a cool guy. I was wearing the white lab coat and everything. And I got up to them and I was like, tell me about Alzofon. What about anti-gravity? Anti-gravity disclosure is where it's at. And this guy pulled me aside. He's like, let's go walk over there. I'll talk to you about Alzofon. And I followed him, through the path that where they are able to leave the lecture hall. And he whispered in my ear, dude, I worked for the Navy. We replicated the Alzofon experiment. The results are classified. That's what he told me there at Alien Con. the results in 2019 were still classified from your dad's experiment. And that was like, holy shit, something's going on. We really need to do Alzofon now.
Yeah, he was shielded by his obscurity during his lifetime. He never got to see one of his vehicles fly. But I will say, at least they left him pretty much alone. There was one call from a drunken officer of the Black World. I won't identify the agency. But that guy had a question about UFOs, and he said, how come they're so damned heavy? I have a question for you. How come they're so damned heavy? If I like your answer, I'll give you unlimited funding. Well, my dad gave him the answer, and he liked the answer, and he offered him unlimited funding, but my dad wouldn't have anything to do with that world. At least he was consistent. So it came to naught. It was the second time that he was offered funds from the government. But
what was the answer?
The answer is that they're so heavy because if you have a heavy object, it will store more nuclear orientation. It's like a balloon that has room for more hydrogen in it. And therefore, a denser material, if you can pump it full of nuclear orientation, which requires more power, you need a better power plant. But let's assume that the weight is run up by the necessity of having a high-powered power plant.
Oh, I get it. It's sort of like matter or mass in and of itself is a reservoir, like a capacitor of electricity. It's a reservoir of nuclear orientation. So if you got these big megalithic blocks and you were to make a pyramid out of it, it would basically just be a massive reservoir of nuclear orientation for the craft.
Another way of looking at it is that the Earth's gravitational field has to penetrate a denser material and more of it in order to have the effect that the Earth's gravitational field normally does, which is to create weight and mass in that object. And therefore, having a very dense vehicle with a lot of molecules in it and a lot of atoms is going to be a better reservoir for the dynamic nuclear orientation or the nuclear orientation effect that gives you zero gravity. That was his explanation. Well, then when you shut it down, it's going to make a deep landing impression in the ground. And this has been observed many times with the UFOs. Their landing gear makes deep marks in the ground, meaning they're heavy as hell.
What's your thoughts on the EM drive, the M drive? It's basically it's a cavity sort of shaped like this, made out of copper, and you are inserting microwave energy into it. For some reason, it moves.
Yeah, I've heard about it. I haven't studied it very much, but from what I've heard, at least, I don't think it has anything to do with my father's technology, except that it would be a useful propulsion system for a vehicle that uses microwaves to defeat gravity. You could just drain off a little bit. And by the way, let's talk about crop circles. You could drain off a little bit of that microwave energy into one of these propulsion systems, and you could fly through space very cheaply and very fast, super fast. But, and right now, the problem with that propulsion system, as I understand it, is it doesn't develop much thrust. Well, if your vehicle has no inertia, it doesn't matter that it develops very little thrust. It's still going to go like a bat out of hell. But to come to the issue of crop circles, my dad wrote an article for the MUFON Journal, and last time I looked, it was online. You can find it. Citation, I don't have it off the top of my head, but I think it was 1994, about then, MUFON Journal, July, possibly. Anyway, crop circles also display this technology, but in reverse, you see. If you seed a field with, often before the crop circles form, you'll see orbs flying around the field. And what are they doing? Well, the theory is they're dropping iron particles on the crops. The iron particles then become a medium for the opposite effect that you use on the vehicle. You project a microwave field down on the iron particles that drives the electrons. It increases the gravitational pull of the Earth in the vicinity of the crop circles. And also because of the way microwave energy swirls around as it leaves the antenna spirals, you get a spiraling effect on the crops that have been seeded. What do you get? A crop circle. And you will get it really fast. People who've seen these circles form say 15 seconds max for a gigantic field. At the same time that these crop circles form, it's often done in cloudy weather. And the idea is that you get the big UFO hovering above the field, not visible to the naked eye because it's inside the cloud cover. And then sometimes they see a column of light coming down from the clouds. This would also be ionization from the microwave field, or incandescence of what's the word, the inert gases in the atmosphere because of the energy.
God, showing off his energy, and we have to worship him for the next couple thousand years.
Maybe they're hoping to get us to worship them too. Who knows?
No, I was just making a joke about Judaism. Because that's what
anyway. Yeah, so you get this swirling effect. Now, some of these crop circles have become exceedingly sophisticated. I think that they probably realize this could be a good medium of communication with us. I think that possibly the medium is the message. They're saying to our scientists, hey, look at what we're doing. Can you figure it out? They don't want to publish in Physics Today or whatever the academic journals are. I'm sure that if they submitted an article, it would be rejected.
I think the key here is that it needs to come out independently. And if anyone who's in the know, who learned about this through the secret space program or through Black Ops, were to come out and publish, it wouldn't be fair because they were given an unfair advantage. So it needs somebody like myself or Jeremy, who's been actively at this their entire life, or just for the short period that I've been, to actually come and try the experiments themselves and see that it really works, to then go and publish, for it to be a fair game at what happens afterward. Because what happens after anti-gravity disclosure will be world changing, pretty fast. As soon as it gets enough traction, there's going to be companies that are gearing up and changing their entire processing plants to start working on this new technology.
Oh, incidentally, because you can transfer the effect without irradiating everything in the vicinity, but say you get an aluminum wires, you could put it on the production floor of an automobile factory and run your robots at supersonic speeds, because there would be no inertia in the armatures. One of the main problems with these robots is speed limitation, is the overbanking of the armatures controlled by the robot gears. But if there's no inertia, they can do everything in seconds that they would have normally taken much longer to do. And it could all be done with the same technology. There's a patent for you.
That I wanted to point out, another thing people don't realize is that China is so much further advanced with all of this stuff than us. And all of our electronics, all the semiconductors, all the material science technology that needs to happen for this technology to become a real thing, it has all been outsourced and sent overseas for the past 20 years. The manufacturing's all been done in China, and
right.
And they are dominating this market now with. I wouldn't be surprised if, I'm just surprised that they haven't shown
Well, there's your Sputnik, but apparently.
Yeah, the Sputnik.
Managers haven't caught on to, the administrative class hasn't caught on to the fact that we're being outflanked.
Oh, they have. It's been in the last national security reports for the past 3 years. Mentions of this have been going on, and there's been numerous reports within the intelligence agencies warning, the U.S. that the production, going overseas to China has caused, a huge gap, a deficit. and the technology over here, and that that we're seeing the effects of all that. And also they did a study with, I think it was one of the defense intelligence, I think it was the DIA, the Defense Intelligence Agency, because of all those computer chips that were coming over from China that were hackable with hackable firmware inside all these Chinese manufactured products that have these call home functions and other such things, features built into the hardware on the boards themselves. It gave like a whole study it gave rise to this whole study that was done about how to get off of Chinese hardware completely, so that we can prevent these hard chips, these spy chips.
I've actually seen that in real life. There are copying machines, and
I have too.
When I was down in Huntsville, they were actually telling me about it, that this copy machine has this Chinese hardware software combination that when it's pinged by its mother company that knows that it's in like some lab somewhere and you're making a copy of some, secret IP, they're sending it straight back to manufacturing there in China.
Right. It's all built in all the Chinese built hardware, and it's been a huge problem for espionage that they've identified and they've commented on. If you read the reports on this stuff, there are these call home functions in several of manufacturing products from China, including Hikvision. I worked for a security camera company that did electronic security systems for all the hospitals and government centers and a lot of other we did some contracting work for Electric Boat down here in Rhode Island and in New London, Connecticut, which builds our nation's submarines and does classified research out there. And they were concerned about these Hikvision cameras, which have this call home function hardwired into the chips on the motherboard, which again, when they're hired into these facilities, that they activate this function in order to try to get copies of intelligence data, so they can get camera feeds from inside plants that are sensitive, So
I don't know whether you guys heard the story, but I heard it on the news last night that 20 U.S. spies in China were arrested and executed by the Chinese government. And the way that they knew that these people were spies is they had hacked our secret communication channels. How do you think they knew how to do that? This is really a serious situation, and I'm worried. I'm worried not just about China, but about any country being able to just walk right into the secret areas within our government research facilities and also within industry and just pick stuff off the computers and walk out with it free. This stuff that takes millions and millions of dollars and millions of man hours to create, just take it for nothing. And also, I think that in general, the Chinese have a much more pragmatic attitude towards research. They are more interested in results. They're very curious about things, that they're not closed-minded the way the academics in the United States have been towards certain physicists that I know, who shall remain nameless, and ignore his work in favor of just keeping the status system stable. What?
Status quo, it's called.
Yeah. And the price will be paid eventually.
Oh, yeah.
If you don't face reality, somebody's going to get it.
Yep.
And somebody may have gotten it.
I mean, the fact that I've gotten this far and, with so little funding, it's literally just pure passion that has gotten me to this point. I think that anybody with decent funding could have gotten here already. And it's just shocking that we're not seeing any flying saucers flying around, I question my sanity sometimes.
Yeah. Yeah. Well,
we do see them. There's like numerous reports. There's like videos of them daily getting posted.
Yep. Yeah, but I'm talking about like in the open world. Why are we?
Yeah. Why is this technology still like top secret and still like a hush hush thing? it's not going to be for long. I feel, especially with the stuff that's come out, like there's been some, there's been a lot of posts about those U.S. Navy patents and stuff, and honestly, I think that's just like it's just a trickle. It's just a drip, drip. There's so much of this stuff that's gone on, and that we're gonna come out. That's gonna come out in the next few years. Um, I don't know. It's going to be
Okay.
interesting to see what happens. But David, your perspective on this, like, how is it to see, like, 30? How long has this been? 38. It's been 38, 39 years since 1981. Um,
Yeah.
I was born in 1982. Just to give some perspective on this, like a year after that. So it's like just looking at this is like right around the time that I was just I wasn't even able to do physics until or even conceptualize anything to do with this until like 20 years into this, like 18, 16, 17 years old. It's when I first started learning about physics and stuff. So it's kind of gives some perspective on this.
Sure. I'd love to give you perspective on it. I've had a dream, like Martin Luther King in a way, of a world of unlimited freedom, of spectacular accomplishments in science, of relief for the population pressure and food resources pressure, new frontiers to explore. Ever since I was 8 years old in 1958, here we are in 2020, soon to become 2021, and this gift, which has been laying out on the uh, shelves of the public libraries and essentially in the air ever since 1981, at least, has not been picked up yet. And it's disheartening. But on the other hand, I haven't lost a belief in the dream. If anything, I believe in it even more than ever. If we're going to survive as a species, we need a technological breakthrough like this. I'm not saying this is the only one we need, but we need energy breakthroughs too. But independent of that, this would improve our chances of survival, and it would give back so much to the hopes of humanity, compared to this nightmarish world we live in now, where we feel resources are scarcer and scarcer. We've got to fight over them. We got to fight over land. We've got to fight over sea. We can't do without weapons of mass destruction everywhere in everybody's hands and just pray that nothing happens. This is the nightmare world we live in. Whereas I dream of a world of unlimited abundance for all, and it's entirely possible. And this technology would be extraordinarily helpful in realizing that world. It's not a starry-eyed thing of idealism. It's an accomplishable fact. Every time we've had breakthroughs like this, it's been science, guided by a consciousness of humanity's needs, not the needs of small groups of individuals for wealth or power or all these other things. Now, that doesn't mean they won't have wealth and power. Yeah, they will, but it'll be shared around more.
And science is pushed forward through technology and through engineering, through actual application of the physical in the physical realm. And that's what I'm striving to do. Right now, I'm noticing in the chat group, there's a lot of people that are clearing out. They're saying it's getting very late. I'm getting very tired myself.
Okay, then. You could break it up.
We definitely need.
hear me. Sorry. Ah, crap. I'm the mute function. I have the mute. I've been. This is why I need the person to join to like control my stream, because they could hear me. You guys could hear me on the Zoom. But anyways, it's a good time to wrap up, guys. You know, we're all tired. It's been on 3 hours now, and we've been going hard with we're gonna edit this down with you know, like a JRE does with Joe Rogan clips, you know, JRE clips, and we'll make some highlights for people, because you know people are going to see a 3-hour video and not have time to dig in. So we'll definitely have to do some highlight reels on this. And David, thank you for taking the time to join us here tonight. And yeah, I've been drinking. I'm sorry. I'm having a good time. We're partying. I've had like 3 beers now. I'm on my 3rd one. It's hour 3 now. I have 1 beer per hour. That's pretty good. You know, I'm not doing shots. You know,
I'm high on adrenaline and big ideas. Right. I'm gonna go get a beer after this is over, though.
Yeah, you deserve one. And and definitely thank you for everyone in the chat for joining us and contributing. You guys, this wouldn't be here without you. And thank you all, for even the trolls, for you know, adding your commentary and stuff. And we'll get David back on here in a couple months after we've done these experiments. We got to get that higher voltage power supply again, the new klystron, and everything else. And we're going to run this. We're going to run this experiment harder and more thoroughly than anyone's ever done it before, David, for you and for your father. And,
I promise this: if we don't get it to fly, we'll vaporize it so it'll fly.
Okay, don't vaporize the lab.
Right. So stay tuned, guys. Stay tuned, and we're going to have some updates for you here in the future with from Mark with Falcon Space, and everyone else in our laboratory. We're working hard to reproduce these results, you know, whatever results we can find, and publish, you know, publish things honestly and realistically, so that people have you know, the right information. And thank you all for watching, and you know, we're gonna see peace out. We're gonna see where this lands in a couple months. We're gonna come back on this and hopefully have some
prosper.
Ringo.
Thank you for an excellent show, man. Thank you so much for joining us. This was wonderful.
Well, thanks for being a great moderator, Jeremy, and I really appreciate the opportunity to speak to a broader audience about what has been essentially a very solitary struggle.
We had like 130 people on, 135 on the live stream, and wow. I think at some point, you know, this is going to be seen probably by more than 10,000 people, especially if you do what you said and cut it up and give out just the nice chunks of the important information.
Yeah,
that's right. It's really where it's at. It's in the editing.
Well, okay. I guess that's time to tie the bow and ribbon on it then.
Yeah, have a good night, and you go enjoy that beer. You well deserved it, and
thanks.
I'll do the same. Thank you all for watching, and have a great night. This has been a pleasure on 10/3/2020, the Alien Scientists. Thank you, everyone.
Good night, everybody.
I'll see you next time. Good night. So long.
So long.